Hi everyone, welcome to PrepFusion. So in this video we are going to study about a unilateral Laplace transform. Now what is this unilateral Laplace transform? Till this point whatever the Laplace transform we were studying, what is the name of that Laplace transform? So we will study all that, but before that you solve this question. So you need to tell the result of these multiplication. Ut multiply with ut will be ut only, right? You draw the graph ut multiplied with ut. So it will be ut only, right? U of t plus 2 multiply with ut. U of t plus 2, that means it will be starting from u of t plus 2, sorry, u of t plus 2, that means it will be starting from minus 2 multiplied with ut. What you will get? Ut only, because this is non-zero, this is here it is 0 and it is non-zero. Non-zero multiplied with 0 will be 0 only. So u of t plus 2 multiplied with ut will be ut only. U of t plus 5 multiplied with ut will be ut only, because u of t plus 5 will be starting from minus 5. U of t minus 2 dot ut, what that would be? U of t minus 2, that means it will be starting from 2. So u of t minus 2 multiplied with ut. So what you will get? U of t minus 2 only, because here this 0 part will be multiplied with the non-zero part, that will become 0 only. This will also be ut. U of minus t multiplied with ut, 0, because u of minus t goes here and ut goes here, both multiply will be 0. U of minus t minus 2 multiplied with ut, u of minus t minus 2, u of minus t minus 2 multiplied with ut. If I multiply both of them, so this is no common part is there, so basically multiplication will be 0. U of minus t minus 4 multiplied with ut, 0. U of minus t plus 2, u of minus t plus 2 multiply with ut. So what will happen? Between 0 to 2 it will be non-zero, so that can be written as ut minus u of t minus 2. See, yes or no? Between 0 to 2 it will be non-zero, so if I multiply both of them, so between 0 to 2 they will be non-zero, so ut minus u of t minus 2, this will be the result. And u of minus t plus 5 dot ut, that would be u of t minus u of t minus 5, right? So this is very basic thing, basics of signal it is, right? You are in the Laplace transform, you are in the last of the chapter, so this much you should be able to tell. Sir, why we are doing so? What is the use of all these things? You will understand why we are doing so, you will understand that. So let's start studying about unilateral Laplace transform. So in this chapter till this point, whatever that we have studied, that was bilateral Laplace transform. What that was? Bilateral Laplace transform. That was bilateral Laplace transform. What was the formula? What was the formula of x of s? In the first slide, what was the formula of x of s we written? Minus infinity to infinity x of t e to the power minus st dot dt. Now in unilateral Laplace transform, what we will consider? The formula will go from 0 minus to infinity. 0 minus to infinity xt dot e to the power minus st dot dt. Did you understand this point? What is the difference between bilateral and unilateral Laplace transform? In bilateral Laplace transform, formula goes from minus infinity to infinity, but in unilateral Laplace transform, formula goes from 0 minus to infinity. Sir, when we will use unilateral, when we will use bilateral, you will get to know. Okay? If nothing is mentioned, then by default you need to take it is bilateral Laplace transform. Sir, then why you need to define unilateral Laplace transform? You will understand that. In this lecture, you will understand why we need to define unilateral Laplace transform. What did you understand? The formula is from 0 minus to infinity xt to the power minus st dot dt. Everything else is same. Now you let me know if yt is equals to xt dot ut, then what will be the bilateral Laplace transform of yt? So what you need to find? Bilateral Laplace transform of yt. Bilateral Laplace transform of yt. Can that be written as bilateral Laplace transform of xt dot ut? Right? What will be the formula? Minus infinity to infinity yt dot e to the power minus st. And what is yt? Yt is xt dot ut. Xt dot ut e to the power minus st dot dt. Since ut is multiplied, so can I interchange my limit from 0 minus to infinity? Because ut is multiplied. Xt e to the power minus st dot dt. Now what is this? What is this particular thing? This is your unilateral Laplace transform of xt. This I can write down as unilateral Laplace transform of xt. Unilateral Laplace transform of xt. So if they are asking you to find the unilateral Laplace transform, what you will find? You will find out the bilateral Laplace transform only, but you will relate these things, that unilateral Laplace transform of xt will be equals to bilateral Laplace transform of ut. What does that mean? What will be the ROC of unilateral Laplace transform? The ROC of unilateral Laplace transform will always be right to the rightmost pole, because if ut is multiplied, what does that mean? It is looking towards plus infinity. That means ROC will also look towards plus infinity, right? So unilateral Laplace transform of xt is bilateral Laplace transform of xt dot ut. So if any day you need to calculate unilateral Laplace transform, you will calculate actually bilateral Laplace transform only. So this is the conclusion. Unilateral Laplace transform of xt is given as bilateral Laplace transform of xt dot ut. So you will multiply your xt signal with ut and then you will calculate its Laplace transform, and ROC of unilateral Laplace transform will be right to the rightmost pole. Why it is right to the rightmost pole? Because ut is multiplied, and if towards any function if you multiply ut, what does that mean? That means it will surely look towards plus infinity. So ROC will also look towards plus infinity only. So right to the rightmost pole. There you go. Okay. So let's find unilateral and bilateral Laplace transform of these functions. So let's take the first one. You need to find the bilateral Laplace transform of e to the power minus t. Does not exist, right? We have studied it, right? Do you remember it? Does not studied writing. I am writing down. I was writing down does not studied. Does not exist. We have studied, right? E to the power minus t. E to the power minus t into 1. Then 1 can be replaced with ut and u of minus t. Ut will say that you look towards plus infinity. U of minus t will say you look towards minus infinity. So 1 ROC will be sigma greater than minus 1. 1 ROC will be sigma less than minus 1. No common ROC. That means bilateral Laplace transform of e to the power minus t does not exist. Now what you need to find? Unilateral Laplace transform of e to the power minus t. What that would be equals to? Bilateral Laplace transform of e to the power minus t ut. Right? That would be equals to e to the power minus t, whatever the function that is written here, multiplied with ut. So what will be the answer? 1 upon s plus 1. What is the bilateral Laplace transform of e to the power minus t ut? That is 1 upon s plus 1, with the ROC being real part of s greater than minus 1. So unilateral Laplace transform of e to the power minus t will be this one. So this is the first answer. And what about the bilateral one? That means it doesn't even exist, right? What about the second one? B. What you need to find? Bilateral Laplace transform of e to the power minus t ut. What is that? 1 upon s plus 1 with the real part of s greater than minus 1. And what will be the unilateral Laplace transform of e to the power minus t ut? That would be bilateral Laplace transform of e to the power minus t ut, whatever the function is there, multiplied with ut. And you know that ut multiplication ut will be ut only. So that will be equals to e to the power minus t ut. And what that would be? 1 upon s plus 1 with the real part of s greater than minus 1. So here this was your bilateral Laplace transform and this was your unilateral Laplace transform. Some relation you can see. Here both are equal. Here both were not equal. So we will write down all those conclusions, but let's see more questions. Bilateral Laplace transform of e to the power minus t u of t minus 1. E to the power minus t u of t minus 1. Right? So how do we solve it? What I need? U of t minus 1 here. And then basically plus minus 1 e to the power minus t minus 1 plus 1 and u of t minus 1. Did you understand this point? This we have already seen. E to the power minus t u of t minus 1. U of t minus 1 e to the power minus t minus 1 plus 1. Because there was e to the power minus t only, but I need t minus 1. That's why I did so. So what I am getting? Bilateral Laplace transform of e to the power minus t minus 1 into e to the power 1 u of t minus 1. So what you are getting? E to the power 1 outside, then 1 upon s plus 1, and since t is equals to t is replaced with t minus 1, so e to the power minus s will also be there. e to the power minus t ut, that will have 1 upon s plus 1. Since t is replaced with t minus 1, so e to the power minus s will also be there, right? And this 1 was already there. So this is the answer we are getting with the real part of s greater than minus 1. So this can be written in a better manner, e to the power 1 minus s, right? And what about the unilateral Laplace transform of e to the power minus t u of t minus 1? So that would be bilateral Laplace transform of e to the power minus t u of t minus 1 into ut, u of t minus 1 into ut. What that answer would be? U of t minus 1 only, right? Here what is written? U of t minus, here u of t minus 1 is written, but I told you unilateral Laplace transform is the same function multiplied with ut. So u of t minus 1 multiplied with ut, what that would be? Bilateral Laplace transform of e to the power minus t u of t minus 1. So isn't this is the same thing? No, this is the same thing. So you will get the same answer, e to the power 1 minus s divided by s plus 1 with the real part of s greater than minus 1. How do we solve it? E to the power minus t is there, t minus 1 plus 1. So there e to the power, okay, e to the power minus 1 is coming out, no, here. E to the power minus t plus 1 and then e to the power minus 1 was there. So this was actually minus 1. So here you will get, this is the answer we are getting. Something wrong I did. Right, here e to the power minus t minus 1 and then minus sign is there, no, so e to the power minus 1 is coming out. So e to the power minus 1, e to the power minus s upon 1 plus s plus 1, right? Because e to the power minus ut, e to the power minus t ut will throw 1 upon s plus 1, and here e to the power minus 1 was there. So this is the answer we are getting, real part of s greater than minus 1. So here also both are coming same, but always it is not necessary, somewhere it will be changing. So we need to have some patience for that, right? Bilateral Laplace transform of e to the power minus t u of t plus 1, e to the power minus, so t plus 1 minus 1 u of t plus 1. So what that would be? Here e to the power 1 will come out, e to the power 1 will come out, dot bilateral Laplace transform of e to the power minus t plus 1 u of t plus 1, e to the power 1 e to the power s, t is replaced with t plus 1, so e to the power s, and e to the power minus t ut, that would be s plus 1, right? Yeah, so e to the power minus t u of t plus 1 was there, so t is replaced with t plus 1 minus 1. So from there what we are getting, e to the power 1 outside, e to the power minus t plus 1 u of t plus 1, e to the power minus t ut will have 1 upon s plus 1. There e to the power 1 is there outside, and from here t is replaced with t plus 1, so e to the power s will come outside, right? So we are getting e to the power s plus 1, e to the power s plus 1. ROC is real part of s greater than minus 1. What about this one? Unilateral Laplace transform of e to the power minus t u of t plus 1. That would be equals to bilateral Laplace transform of e to the power minus t u of t plus 1 into ut, right? And what this would be? U of t plus 1 into ut, starting from minus 1 and this is starting from 0. So this would be equals to bilateral Laplace transform of e to the power minus t ut. And what is the answer you will get for this one? 1 upon s plus 1, right? With the real part of s greater than minus 1. So here both are different. Again both are different. So what kind of signal it was? U of t plus 1. It was non-causal signal. What kind of signal it was? It was a causal signal, right? What kind of signal it was? Causal signal. So for causal signal, unilateral and bilateral Laplace transform are same, and it is very obvious as well, because causal signal will start from 0 to infinity. It can go from 0 to infinity. So even in the basic formula of a bilateral Laplace transform, minus infinity to 0 will be 0 only. Are you able to understand what I am saying? What I am saying, bilateral Laplace transform of a causal signal will be equals to unilateral Laplace transform of a causal signal, because causal signal are 0 for t less than 0. Causal signal are 0 for t less than 0. That means here this limit which is going from minus infinity to infinity, I can break it down like this: minus infinity to 0 minus, and then from 0 minus to infinity. So this part will throw 0 only, because xt will be 0 in this part. So this part will throw 0 only, and here you will get xt e to the power minus st dot dt, which is equivalent to unilateral Laplace transform only. But you don't need to remember in this manner. We have seen the examples, right? What this was? This was a non-causal signal. This was a non-causal signal, but this was a causal signal. This was a causal signal. This was a non-causal signal. This would be also a non-causal signal. This would be a anti-causal signal, and this would be a anti-causal signal, right? Now let's see for anti-causal signal what happens. For the anti-causal signal, your unilateral Laplace transform will be equal to 0. Why is that so? You can think about it. So let's find out the e to the power minus t u of minus t. So e to the power minus t u of minus t. What was its bilateral Laplace transform? 1 upon s plus 1. Since there is u of minus t, so another negative sign would come. Real part of s greater than minus 1, right? Now what about unilateral Laplace transform of e to the power minus t u of minus t? That would be equals to bilateral Laplace transform of e to the power minus t u of minus t dot ut. So what is the multiplication of these two? 0. So bilateral Laplace transform of 0, that would be 0 only. So what is the answer you are getting? Here you are getting 0, and here something you are getting. So for a non-causal signal, sorry, for an anti-causal signal, unilateral Laplace transform will be 0 only, because in the unilateral Laplace transform you take the limit from 0 minus to infinity. But in case of anti-causal signal, from 0 minus to infinity, everything is 0 only. So that's why it will throw 0 only, which is pretty obvious. Very easily you can think. F e to the power minus t u of minus t minus 1. E to the power minus t u of minus t minus 1. So here what I can do, how will I write down the bilateral Laplace transform of this one? So let's write down the bilateral Laplace transform of u of minus t. That would be minus 1 by s. Then what do I do? T is replaced with t plus 1. So what do I get? E to the power s divided by s. Here t is replaced with t plus 1. Now if I multiply e to the power minus t, then what will happen? In any way I could have written down, just a different method I am trying. So e to the power minus t. So s will be replaced with s plus 1 actually. S will be replaced with s plus 1. There you go. This is the answer. This would be minus e to the power s plus 1 divided by s plus 1. Otherwise you could have gone with this method as well. T is replaced with t plus 1. T plus 1 minus 1. And here u of t is replaced with t plus 1. So here what we are getting? E to the power minus t plus 1 u of minus t plus 1. So e to the power minus t ut 1 upon s plus 1. T is replaced with t plus 1, that means e to the power s would come, and here already 1 is there. So e to the power s plus 1 divided by s plus 1. And yeah, another negative sign will also come, because e to the power minus t u of minus t will throw negative of 1 upon s plus 1. So this we have already seen. These bilateral Laplace transform like 10 times we have seen it. Till this point you should be able to write down all these things. Now coming to unilateral Laplace transform of e to the power minus t u of minus t minus 1. So that would be equals to bilateral Laplace transform of e to the power minus t u of minus t minus 1 into ut. What this multiplication will throw? U of minus t minus 1. U of minus t minus 1 dot ut. That will throw 0. Again for anti-causal you are getting 0, and here you are getting something else. G, bilateral Laplace transform of e to the power minus t u of minus t plus 1. So now here you are not going to get 0. E to the power minus t u of minus t plus 1. So how will you do it? E to the power minus t plus 1 minus 1, and here u of minus t minus 1, right? So e to the power minus t minus 1, and then e to the power minus 1 will be outside, and u of minus t minus 1. So e to the power minus t ut, e to the power minus t u of minus t, another negative sign, e to the power minus s. right? So minus e to the power minus s plus 1 divided by s plus 1. This is what we are getting. So minus e to the power minus s plus 1. Now you should be comfortable with all these analyses, okay? I don't want myself to explain that from 0 this is how it will start. No, nothing like that. Look, from very basics we have seen it. A to the power minus t plus 1 minus 1, u of minus t minus 1, u of minus t minus 1 here. Here also I would need t minus 1 only. So a to the power minus t, t minus 1, and e to the power minus 1 will be outside. So e to the power minus t, u of minus t will throw 1 upon s plus 1 with the negative sign, and e to the power minus 1 is already there, and since there is t is replaced with t minus 1, so e to the power minus s will also come. So e to the power minus s, e to the power minus 1 will be e to the power minus s plus 1, and then there is a negative sign. So this will be the answer you will be getting. And what about the bilateral Laplace? What about the unilateral Laplace transform? So unilateral Laplace transform will be multiplied with this. So u of minus t plus 1 multiply with ut. What you will be getting? Ut minus, what this will throw? Ut minus u of t minus 1. Ut minus u of t minus 1. So that would be array r. This would be equals to bilateral Laplace transform of e to the power minus t, u of minus t plus 1 into ut. So this would be equals to bilateral Laplace transform of e to the power minus t, u of t minus e to the power minus t, u of t minus 1. Is that clear to you? Right? Are you understanding this point? U of t minus 1 into ut will throw ut minus u of t minus 1. So this is something different. This is something that I have separated, right? So now e to the power minus t ut 1 upon s plus 1 minus e to the power minus t. So t minus 1 plus 1 I will do, and then u of t minus 1. So e to the power minus 1 will be outside, 1 upon s plus 1 e to the power minus s. So e to the power minus s plus 1 upon s plus 1. So this is the answer we are getting with the ROC, real part of s greater than minus 1. So this is the answer we are getting. So here this was the answer, and here this is the answer we are getting. Right? Well and good. Okay. Here we are calculating the bilateral Laplace transform. So bilateral Laplace transform of this one I can write down, right? Bilateral Laplace transform of this one I can write down on my own. So this is how I have written it down. Well and good. Okay, so this is the answer, 1 upon s plus 1 minus e to the power minus s plus 1 upon s plus 1. But here the thing is, here what will be the ROC? ROC will be entire s plane. Here the ROC will be entire s plane. Think about it. Why is that so? Because this has become a finite duration signal. E to the power minus t multiplied with ut u of t minus 1. So ut u of t minus 1 multiply with e to the power minus t. E to the power minus t, this is the, so this has become a finite duration signal actually. So for a finite duration signal, ROC is always the entire s plane. So ROC here will be entire s plane, right? Because this has become a finite duration plus a finite amplitude signal. And even if you put s equals to minus 1 here, you can see that e to the power 0 will be 1. So 0 by 0 form you are getting. So yeah, surely ROC will be entire s plane here. So here what I will write down, right to the rightmost pole or entire s plane, right? So this is the conclusion we can see, that for anti-causal signal, unilateral Laplace transform will be 0. For causal signal, unilateral Laplace transform and bilateral Laplace transform will be same. And for non-causal signal, both will be different. This is the conclusion we have made. So what is the conclusion? For anti-causal signal, unilateral Laplace transform is 0. For a causal signal, unilateral Laplace transform will be equal to bilateral Laplace transform. For a non-causal signal, unilateral Laplace transform is equal to bilateral Laplace transform. And for some signal, bilateral Laplace transform may not exist, but unilateral Laplace transform exists. Where is the example? Here is the example. That for this particular signal, bilateral Laplace transform was not existing, but unilateral Laplace transform was existing. So from now onwards I will call it ULT, and this I will call as BLT. So ULT exists, BLT doesn't exist. So this kind of question can be coming in 1 mark, which of the statement is true. Okay, so these are the two statements. Anti-causal 0, causal ULT is equals to BLT, non-causal ULT is not equals to BLT, and for some signal BLT may not exist but ULT exists. Okay, so nothing you need to mug up. You will be able to think causal, okay, multiply with UT, both same. Anti-causal, multiply with UT, ULT will throw 0. Non-causal, both will be different, multiply with UT, both will be different. So both, if both are different, that means different results would be there. And for some signal, like the signal which are both sided, e to the power minus t. So e to the power minus t, for this your unilateral Laplace transform, your bilateral Laplace transform may not exist, but unilateral Laplace transform will exist. More examples you can see. Like what is the bilateral Laplace transform of sin omega naught t? It is a periodic signal, right? Does not exist. Does not exist. But let me know what will be the unilateral Laplace transform of sin omega naught t. So I told you one thing, that unilateral Laplace transform of sin omega naught t will be equals to bilateral Laplace transform of sin omega naught t ut, and that will throw omega naught upon s square plus omega naught square, where ROC will be, or I should say real part of s greater than 0. This would be the ROC. So just multiply this signal with ut and your job is done, right? So here it will not exist, but here it will exist. So unilateral Laplace transform of xt is 1 upon s plus 1. You let me know what all are the possible chances of xt. Do it on your own. What I am saying, 1 upon s plus 1. This is your Laplace, unilateral Laplace transform. What could be your xt? So I am saying that my xt could be e to the power minus t. Is this true? Yes, because unilateral Laplace transform of e to the power minus t would be equals to bilateral Laplace transform of e to the power minus t ut, and that would be equals to 1 upon s plus 1. Whenever they define unilateral Laplace transform, they will not tell about the ROC actually. Okay, they will not tell that real part of s greater than minus 1. It is by default. They would know that if you are writing down unilateral Laplace transform and poles are finite, that means ROC will be right to the rightmost pole. So by default, in your mind, you need to consider that ROC will be real part of s greater than minus 1 only. So it would be coming from e to the power minus t, or it would be coming from e to the power minus t ut. Are these only two possible? No. Or it could be coming from e to the power minus t u of t plus 1 as well. Why is that so? This you already know, right? E to the power minus t ut will have a unilateral Laplace transform of 1 upon s plus 1. What will be the unilateral Laplace transform of e to the power minus t u of t plus 1? U of t plus 1. That would be equals to bilateral Laplace transform of e to the power minus t u of t plus 1 dot ut. So t plus 1 dot ut. So starting from minus 1 to infinity dot ut. So both being multiplied will be equals to ut only. So that would be equals to bilateral Laplace transform of e to the power minus t ut. So what we will get? 1 upon s plus 1. So here e to the power minus t u of t plus 1 will get 1 upon s plus 1 only. More things could be there. What those would be? Those would be e to the power minus t u of t plus 2 as well, because u of t plus 2 dot ut will be the same. So in that manner, a lot of things could be there, right? In that manner, a lot of option could be there. A lot of options could be there. Are you able to understand this point? U of t plus 3, u of t plus 4, u of t plus 2.5, u of t plus 2.3. So here 1 upon s plus 1 in case of bilateral Laplace transform. In case of bilateral Laplace transform, this is your ULT. 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 But in case of bilateral Laplace transform, only two things were possible. But in case of unilateral Laplace transform, a lot of things are possible. Right? Are you able to understand this point? So it would be coming from either from e to the power minus t ut or e to the power minus t u of minus t minus sign in case of bilateral Laplace transform. So which one is common in both of them? This and this. So mostly we will talk about only these two. Okay. When I say you need to write down the inverse unilateral Laplace transform of 1 upon s plus 1. If I say you need to write down the inverse unilateral Laplace transform of 1 upon s plus 1, then these two should come in your mind. Forget about these one. Okay. There are a lot of like that, but only these two should come in your mind. Why I am saying so, you will understand that. Have some patience. Practical scenario we did not even discuss till now. Right? We did not even discuss the practical scenario where practically we are going to use. Till this point we were studying bilateral Laplace transform only. Okay. So if nothing is mentioned in your examination hall, you will consider bilateral Laplace transform only. And questions usually come from bilateral Laplace transform, those ROC and all these kind of things, causal, non-causal signal. But this is in the last we are studying unilateral Laplace transform. Where it will be used, why we are studying, so you will understand that. So whenever I say 1 upon s plus 1 is there, and you need to think of unilateral Laplace transform. So what should click in your mind? One signal where there is nothing, no ut is connected, u of t plus 1, u of t plus 2, u of t minus 1, nothing is connected. So this one would be e to the power minus t. And other one would be where ut is connected. That's it. Okay, two signals should click. If I say what will be the unilateral Laplace transform of omega naught upon s square plus omega naught square, sorry, inverse unilateral Laplace transform. So what two signals should click in your mind? If I talk about bilateral, then what two signal will click? Sin omega naught t ut and sin omega naught t u of minus t with the negative sign. But if I talk about unilateral Laplace transform, so which two signals will click? Sin omega naught t ut and simple sin omega naught t. So two signals will click. Those will be sin omega naught t and sin omega naught t ut. Now someone will say that, sir, sin omega naught t u of t plus 1 is possible. Yes, it is possible, but only these two should click. Why I am saying so, you will understand that. Have some patience. Okay, you will surely understand that. Have some patience. So did you understand the point? A lot of are possible, but only these two we will consider. Xt equals to delta t. What is the unilateral and bilateral Laplace transform? So for bilateral Laplace transform of delta t, just simply apply the formula minus infinity to infinity delta t e to the power minus st dot dt. So this t equals to 0 goes here, minus infinity to infinity delta t dot dt, that is 1. And if I talk about unilateral Laplace transform, so delta t ut is ambiguous, right? What will be the result of delta t ut? You don't know, so simply apply the formula 0 minus to infinity delta t e to the power minus st dot dt, 0 minus to infinity delta t dot dt. So you know that what will be the result? 1. So unilateral Laplace transform of delta t is equals to bilateral Laplace transform of delta t, and that will always be equals to 1. So if 1 is written, that means delta t, be it Laplace transform, Fourier transform, anything. If 1 is written, 1 means delta t. Is that okay for you? Now we are going to see the differentiation property of unilateral Laplace transform. So from here we will understand the actual use of unilateral Laplace transform, that where we are going to use the unilateral Laplace transform. So first let's see the property. For bilateral Laplace transform, do you remember the property? For bilateral Laplace transform, if x of t is having x of s, so dxt by dt will have s x of s, s x of s, d square xt by dt square will have s square x of s, and so on. This was for bilateral, because whatever that we have studied till now, that was bilateral Laplace transform only. But for unilateral, the property is if xt is having x of s, this is the unilateral Laplace transform. So the unilateral Laplace transform of dxt by dt will be s x of s minus x of 0 minus. What is this x of 0 minus? So there would be a signal xt, no? So x of t, value of x of t at t equals to 0 minus will be equals to x of 0 minus. So this is the meaning of x of 0 minus. What about this d square xt by dt square? That would be s square x of s minus x of 0 minus minus x dash of 0 minus. How did this formula came? I will tell you, but you need to remember it. And what is the meaning of x dash of 0 minus? That means dxt by dt at t equals to 0 minus, that would be x dash of 0 minus. So how this formula came? D by dt of dxt by dt. So what is the Laplace transform of this one? That would be s into Laplace transform of this one, s x of s minus x of 0 minus, minus the value of this particular function. Here what we were doing, dxt by dt. In dxt by dt what we were doing? First we were putting s, then Laplace transform of this one. What was that? X of s minus value of this particular function at t equals to 0 minus. Here what we will do? Laplace transform of this one. What is that? So by d by dt, for d by dt I will put s. Here d by dt I will put s. Then Laplace transform of this one. What is that? S x of s minus x of 0 minus. Right? Then minus sign, minus sign. Then what we put? The value of xt at t equals to 0 minus. So here what we will put? Value of dxt by dt at t equals to 0 minus. Dxt by dt at t equals to 0 minus. That can be written as x dash 0 minus. So this is how we got it. S square x of s minus x x s x of 0 minus minus x dash 0 minus. So you can write down somewhere. Okay. So in the similar manner, if I write down what will be your Laplace transform of d cube xt divided by dt cube. So that would be s cube of x of s minus s square x of 0 minus minus s x dash of 0 minus and then x double dash of 0 minus. Will you be able to remember? You will be able to remember. You have to remember. There is no other chance. Okay. At least this one and this one you need to remember. So xt x of s, then s x of s minus x of 0 minus. Here s square x of s minus s x of 0 minus minus x dash 0 minus. Basically here differentiation was done one time. So here there is no differentiation. Here differentiation was done 2 times. So in the last there will be one differentiation. Here differentiation has been done 3 times. So in the last there will be 2 differentiation. 1 differentiation, 0 differentiation. 2 differentiation, 1 differentiation. In that manner you can remember. So at least these 3 you need to remember. S square x of s minus s square x of s minus s x of 0 minus minus x dash 0 minus. 2 differentiation, 1 differentiation. 3 differentiation, 2 differentiation. Okay. So you need to remember these results. So these are the property which is different. Rest all properties are same. For unilateral and bilateral, rest all the properties are same. Actually, we will never apply any property in unilateral Laplace transform. What we will do, if someone is asking you unilateral Laplace transform of a particular signal, what you will do? You will find out it's a bilateral Laplace transform multiplying with ut. Right? If I am asking you unilateral Laplace transform of xt, you will not find unilateral Laplace transform of xt. You will find bilateral Laplace transform of xt dot ut. So very rarely you will have to apply the property, but differentiation property will be used. Okay, so this property will be used and that we are going to see now. So try remembering these results and then we will proceed to our concept now. So now this question is given. Ft plus f dash t is equals to xt and f of 0 minus is equals to 2. So you let me know one thing. In bilateral Laplace transform, if you apply the differentiation property, in bilateral Laplace transform, if you apply the differentiation property, so there is no initial condition. No initial condition. Right? So in bilateral Laplace transform, we never consider the initial condition, but in unilateral Laplace transform, we always consider the initial condition. Initial condition means the value at 0 minus. 0 minus value at just before 0. So initial conditions are there. That means initial conditions are into action. Initial conditions are in the action. And all the practical circuit starts after a particular time. What do I mean? There is a laptop. You will start this laptop at a particular time, no? Or this laptop is always on. No. You opened this video at a particular time. You clicked on that video and that video got opened at that particular time. It's not that the video was always open in your laptop. No. So every system always start after a particular time. Like I make a system of RC circuit. but after a particular time I will apply a voltage here, and whatever the time I apply the voltage, that time is considered as 0 time. So for this circuit, this is the starting point. Here your circuit is starting. Any chip, anything will start after a particular time. So in real world analysis, unilateral Laplace transform is highly used, because unilateral Laplace transform takes initial condition into action. But for bilateral Laplace transform, there is nothing called initial condition, because bilateral Laplace transform takes the integration from minus infinity to infinity. But unilateral says that I will start from a particular time, right? So this particular time could be anything. Someone is starting at 2 a.m. So for that 2 a.m. will be t equals to 0. Someone is starting at t equals to 5 p.m. So that 5 p.m. will be t equals to 0. Now in some circuits, sir, you will say that, sir, we have seen that the switch is getting closed at t equals to 1 second. So this t equals to 1 second will be t equals to 0 second for this particular circuitry. So this t equals to 1 second will be the initial condition for this particular circuitry. That for t less than 1 second, here the capacitor was having some voltage. Now just as the switch goes closed at t equals to 1 second, now the circuit will come into action again. Are you able to understand this point? So all the circuits, all the practical system will start from a particular time. And if there is some initial condition given, so you have to apply the unilateral Laplace transform. So if this kind of questions are there in your examination hall, where initial condition is mentioned, now I could have mentioned this initial condition as 0 as well, that f of 0 minus is equals to 0. Still you will apply unilateral Laplace transform only. Even though initial condition are 0, if initial condition are given, you will apply unilateral Laplace transform only. Is that okay for you or not? Did you understand this point? So now here, this particular question will be solved from unilateral Laplace transform, because initial conditions are given. So I need to wait. We will solve this question, and some very good points we are going to understand from this particular question. So I will take a pause, because it has been roughly around 40 minutes, and then I will come back and I will solve this question. Then we will discuss about a practical circuit. Here a bit of network analysis will be used, and after that we will see more concept and some more questions as well. Okay. So a very good discussion we are going to get. So after a break I will come back. Yeah, welcome back. So let's start this question. Instead of f, let's write down y here, because it will be easy for you then. Okay, you will be able to relate the things in a better manner. So let's write down y. So the relation is given somewhat like this. Okay. So let's solve this question. So this is the equation given: yt plus dyt by dt is equals to xt. Right. Now what I need to do, I will apply the Laplace transform, unilateral Laplace transform. So yt will have y of s, dyt by dt will have s y of s minus y of 0 minus is equals to x of s. We will put the values later on. Okay. As of now, let's just see it. 1 plus s is equals to y of 0 minus plus x of s. So what would be your y of s? Y of s is coming out to be y of 0 minus divided by s plus 1 plus x of s divided by s plus 1. So this is the value of y of s you are getting, right? From here, if you need a transfer function, what do you understand by this? That there was an input of xt and you are getting the output yt. This is the scenario. There was some system that you don't know. So input was xt and you received the output yt. So based on that, the equation you wrote, that was yt plus y dash t is equals to yt plus y dash t is equals to xt. So this is the input output relationship. Based on that, can you tell me whether this system is LTI or not? Yes, it is an LTI system. From differential equation, how will you get to know whether the system is linear, time invariant, causal, and causal, non-causal? All these things we have already seen, right? So from the differential equation, can you tell this is a LTI system? Yes. So this is an LTI system. Now in LTI system, what is your transfer function? H of s is given as y of s divided by x of s. X of s. So what you need to find? Y of s divided by x of s. From this equation, can you find y of s divided by x of s? No. Can you find y of s divided by x of s? So if I divide by x of s, so this will also be divided by x of s, and then this part will be gone. So still you are not getting y of s divided by x of s. So here x of s expression is again. So y of s divided by x of s is coming out to be y of 0 minus divided by s plus 1 into x of s plus 1 upon s plus 1. So purely y of s divided by x of s you required, but in the expression of y of s divided by x of s, you are getting the expression of x of s again. So you cannot get y of x divided by x of s from here. So what you need to do? You need to kill this particular part. That means you need to put initial conditions equals to 0. Initial condition is y 0 minus is equals to 2. But what you need to do? This is known as initial condition. Initial condition. Why it is known as initial condition? Initial condition means the value of output at 0 minus. The input came at t equals to 0. The input came into action at t equals to 0. But before the input came, there was some value of output that was 0 minus. So at t equals to 0 minus, what was the scenario? Where I should make? Here I will make. At t equals to 0 minus, what was the scenario? The scenario was there was no input. There was no input, but still there was some output. I don't know what is the impulse response here. I don't know anything, but still there was the output which was 2. So there was no input. Input was 0. Here there was no input. Still there was some output. But if you need to find h of s, what you need to do? You need to nullify this initial condition. You need to forget this initial condition. So you need to put initial condition is equals to 0. So if I put initial condition equals to 0, if I put this equals to 0, then what I will get? Y of s divided by x of s as 1 upon s plus 1. Right? From here I can see that this is my h of s, which is 1 upon s plus 1. So this is your transfer function of your LTI system, which is 1 upon s plus 1. Now what is your output you are having? Y of s as y of 0 minus upon s plus 1 plus x of s upon s plus 1. So if your xt was 0, if xt was equals to 0, what does that mean? X of s was 0. Instead of writing if, I should write when. When your xt was 0. When your xt was 0, what does that mean? When your x of s was 0, what was your output at that time? Output was y of 0 minus divided by s plus 1. So even if you don't apply any input, still you will have this output. So this is known as 0 input response. This is your ZIR, 0 input response. That means even if you don't apply any input, still you are getting some output. So this is known as your 0 input response. Are you able to understand this point? So this is your 0 input response. And when your initial conditions were 0, let's just say I am saying that my initial condition is 0. If my initial condition is 0, if I am saying that my initial condition is 0, although it is not 0, although it is not 0, it is equals to 2. But if I am saying that my initial condition is 0, then what will be your y of s? Y of s is this thing. So what it is known as? 0 state response. That means there was no state for before t equals to 0. So for t less than 0, there was no state. So this is known as 0 state response. 0 state response. So there are two kind of responses. 0 state response, ZSR. So in every output yt, there are two kind of responses: 0 input response plus 0 state response. 0 input response is known as when xt was 0, then what was your output? And 0 state response is known as when your initial conditions were 0, what was your output? So 0 input response, when you will get it? When, or I should write if xt is equals to 0, 0 input response. And when you will get 0 state response? When, or I should write if initial conditions are 0. Initial conditions are 0. And from here you can get your h of s as well. So from here you can get your h of s, which is 1 upon s plus 1. So h of s is 1 upon s plus 1. So now let's write down your output yt. So again let's come to y of s, that is y of 0 minus divided by s plus 1 plus x of s divided by s plus 1. X of s is ut, xt is ut, so xt is ut. So x of s is 1 upon s, and y of 0 minus is given as 2. So what you are getting, 2 upon s plus 1 plus 1 upon s into s plus 1. How you can open it? Y of s as 2 upon s plus 1 plus 1 upon s minus 1 upon s plus 1. Now you need to write down yt. What will be the inverse Laplace transform of 2 upon s plus 1? 2 e to the power minus t ut. Is that correct? No. What we are applying? We are applying the unilateral Laplace transform. So I told you 1 upon s plus 1 can have multiple answers, e to the power minus t as well, e to the power minus t ut as well, and then other answers were also there. But I told you I need to focus on these two only. So let's just say case number 1, I am writing my yt as 2 e to the power minus t ut, because I told you you need to focus on two guys. Plus 1 upon s will have ut, and minus 1 upon s will have ut, and minus e to the power, this is also having ut. So all the inverse Laplace I am writing with respect to ut. Everywhere I am connecting ut. We are doing it. Let's try what happens. So what I am actually writing down, 2 e to the power minus t ut plus 1 minus e to the power minus t ut. This is what I have written. Let's see whether this answer is correct or not. So what is given? That y of 0 minus is equals to 2. This is given, no? Y of 0 minus is equals to 2. So let's put y of 0 minus here. What you are getting? 0 minus. What is the value of u of 0 minus? 0. Plus 1 minus e to the power 0 minus whatever it is. What is the value of u of 0 minus? That is also 0. So 0 plus 0. What is the answer? 0. But it is not equals to 2. So this answer is wrong. This answer is wrong. So when you connected ut on both of the sides, that was wrong. Let's try connecting. Let's not try connecting any ut. Let's write down directly. So 2 upon s plus 1 will have 2 into e to the power minus t, plus it will have 1, and this will have e to the power minus t. Right? Let's try finding the value of y of 0 minus. So 2 e to the power 0 minus, that would be 1 plus 1. Luckily you got it correct here. Okay. This is luck. This is by luck. Okay. Surely it is not sure that every time you will get it correct. So, okay. Luckily you are getting it equals to 2. Luckily. Here I am writing down luckily. But actually this is not correct. Why it is not correct? Okay. I should have framed the question in a better manner. Luckily here what we are getting, here we are getting the correct answer. This is equals to 2. Here you are getting, and this is 2 only. But what would be the actual way? This is also wrong actually. Okay. This is also wrong. So what will be the actual way? Actual way will be yt equals to, when you write down the 0 input response, this was your 0 input response and this was your 0 state response. So when you write down the 0 input response, at that time you will not write any ut or anything. That means you will write it complete, both sided signal. But when you write down the 0 state response, at that time you will write down ut. Why do you think why it happened? Why I am writing down ut here and why I am not writing down anything here? Along with that, I will put a condition that t should be greater than or equals to 0 minus. 0 minus, mark this thing, t greater than or equals to 0 minus. If I am writing down ut, that means 0 minus is not into action. Here I am not writing down ut, that means 0 minus is into action. And here I am putting t greater than or equals to 0 minus, that means this 2 e to the power minus 2t is there at t equals to 0 minus only. So let's understand what is the meaning. For 0 input response, why I did not add ut? So what is the meaning of 0 input response? When input was not applied, what was the output? What was your 0 input response? When input was not applied, what was the output? That means this output was there at t equals to 0 minus as well, no? That means for t less than 0 as well it was there. This portion of output was there this portion of output was there for t less than 0 minus as well. Do you agree with this point? So this was existing at t equals to 0 minus as well. But what is this output? This output was there when the input came into action. This output was there when input came into action. This is coming because of input and this is coming because of 0 minus. So when input came into action, the input came into action at t equals to 0. The input came into action at t equals to 0. So input itself is ut. That means it is coming into action at t equals to 0 only. So that's why the output will also come after t equals to 0 only, no? The applied input was there at t equals to 0. After t equals to 0, the input is starting. So output will also start after t equals to 0 only, no? So this will start for t greater than 0 only, no? Or equals to 0. So for the whole condition, I can write down t greater than equals to 0 minus. How? What will happen here? What will happen? If I write down, if I ask the value of y of 0 minus, what that would be? Here you put 0 minus. 0 minus means 0 only. Plus 1 e to the power 0 minus and here u of 0 minus. What is the value of u of 0 minus? This will be 0. So for t equals to 0 minus, only this part is there into the action. Are you getting this point? For t less than 0 minus, only this part is there into the action. After that, whole part will come into action. If I say at t equals to 0 minus, this part will be gone, but this part will be into action. So this will throw 2. But if I say at t equals to 1 second, so at t equals to 1 second, this will also be into action and this will also be into action. So at t equals to 1 second, if you find out the value here, here or here, everyone will give you the same result at t equals to 1 second. But at t equals to 0 minus second, the results were different here. Even though here also the results would have been different, luckily we got the correct answer. So this is the correct way. What is the correct way? That you write down 0 input response without any ut or anything. But when you write down 0 state response, you need to see when the input is coming into action. Input is coming into action at t equals to 0. So here I need to add ut. So this is the correct this is the correct answer. Along with that, I will add up another thing. Just 1 second, guys. Along with that, I will add up another thing, that is t greater than equals to 0 minus. Now someone will say that, sir, why you add up this thing? What if someone asks you at t equals to minus 1 second, what was your output yt? So can you put t equals to minus 1 second and here you will say that, sir, output was 2 by e. Sorry, output was 2e. At t equals to minus 1 second, your output was 2e, because I put t equals to minus 1 here, so it would be 2e. And at t equals to minus 1, this will not be into action. So at t equals to minus 1, your output was 2e. Who said that? You don't know. The given thing is that your output at t equals to 0 minus is 2. Before that, what is the output? Nobody knows. Nobody knows what is the output for t less than 0 minus. That means you already know the output at t equals to 0 minus. That's it. After that, you don't even know your output. Are you able to understand this point? You already know the output at t equals to 0 minus only. You don't know the output at t equals to minus 1. But if you put the value here, you are getting some answer that is 2e, which is wrong, no? You don't know. Who knows what is the output at t equals to minus 1? So that's why here I need to write down t greater than equals to 0 minus. Is that clear to you or not? So this is the correct way. This is the correct expression of yt. 2e to the power minus t, where I don't add any ut because it is coming from 0 input response. For 0 state response, I will add up ut. Let's understand it more with respect to circuit analysis. So what we are going to do? We are going to understand the same scenario with respect to circuit analysis. So now this time, this is your circuit. This is your system. This is your system where applied input is xt and output is yt. So this is my system. Applied input is xt, applied output is yt. Sorry, applied input is xt and received output is yt. I don't know what is the transfer function here. I don't know that. Well and good. Okay. Initial condition is given, y of 0 minus as 2 volt. So even when the input was not there, still there was some output. So can you write down the equation between xt and yt? The equation should be purely in the terms of xt and yt. So let's write down. So I am applying KVL. This is a voltage, this is also a voltage. So from here I can write down the KVL in this manner, IT into R plus this is the voltage YT. Now those who know the basics of circuit analysis, they would know that from the capacitor, if IT current is flowing, then the voltage across the capacitor can be given by, or you can say the current from this capacitor, and the relation between current and voltage would be C dyT by dt. I hope you guys know this thing. IT will be equals to C dyT by dt. So if I am saying that across the capacitor YT is the voltage, then what will be the current? IT equals to C dyT by dt. So here what I can put, XT will be equals to, in place of IT, what I am putting, in place of IT I am putting C dyT by dt plus YT. Right? So what is the value of RC? RC is equals to 1, R equals to C equals to 1. So what you are getting, dyT by dt plus YT is equals to XT. So this is the relation we are getting. From here you need to tell the value of YT. From here you need to tell the value of YT. So what will be the value of YT you will be getting? So I am applying inverse Laplace. Sy of s minus y of 0 minus plus y of s is equals to x of s. So from here the same thing we are getting which we have done in the previous problem. So y of s will be equals to y of 0 minus upon s plus 1 plus x of s upon s plus 1. So your YT would be, what is this? This is your zero input response. Even when the input was not there, still this was the output, and this is known as your zero state response. And I told you, if I write down YT, how will I write it down? E to the power minus t plus, here I will not add any UT, but here I will add the UT. And what is your x of s? X of s is 5 by s, and y of 0 minus was 2 as well. So let's write down y of s as 2 upon s plus 1 plus 5 upon s into s plus 1. So you can solve it. From here what you will get, 2 e to the power minus t plus 5 1 minus e to the power minus t ut. So this is the correct answer. Along with that, here what I will write down, t should be greater than equals to 0 minus. This is the correct answer. But according to circuit analysis, if this question was there in network theory, and I asked you the value of YT, how would you write down the YT? So what I am writing down, according to network analysis, according to network theory. Okay, if in network theory this question was there, how would you write down your YT? So YT would be, what you used to do, that you used to see the condition at t equals to 0, that was 2 volt, and at infinity it will be equals to 5 volt, because at infinity capacitor will be open circuited. So this is how you used to write down that voltage at infinity, then e to the power minus t by tau, where tau is RC. Sorry, voltage at infinity minus voltage at, voltage at infinity plus voltage at 0 minus voltage at infinity. So this is how we used to write down 5 minus 3 e to the power minus t, RC value is 1. So this is how you used to write down, and we used to add ut here as well. Actually this expression was wrong, because if someone asks you from here, what is the value of y of 0 minus? So you will say, sir, 5 e to the power here 0 minus u of 0 minus. What is the value of u of 0 minus? 0 only. So from this particular expression, what you are getting? 0. So how this was correct? This was actually wrong. But still we used to write down, and we did all the calculation, we were getting the correct answer. Why is that so? Because in network analysis, we always used to discuss for t greater than equals to 0. We don't use to take the condition of 0 minus. What I mean to say, if someone asks you, write down this equation for t equals to 1 second. So how will you write down? For t equals to 1 second, 2 e to the power minus t plus 5 1 minus e to the power minus 1 into u of 1. What is u of 1? 1 only. So what you are getting? 5 minus 3 to the power minus 1. This is the value of at 1 second. So at 1 second, this is the result you are getting. And here, what will be the result you will be getting at 1 second? From this equation, that will also be 5, 3 e to the power minus 1, and then u of 1 you put here. That will be 1 only. So this result and this result, both are same. So this result, even if you add ut or you don't add ut, you add ut here, there, nothing. If you are talking for t greater than equals to 0, then both will throw the same result. If you are talking for t greater than 0, then both equations will throw the same result. Only at t equals to 0 minus the issue will come into action. Only at t equals to 0 minus there will be a problem. Because at t equals to 0 minus, this is giving you the wrong result. This is giving you the wrong result. So for t equals to 0 minus, this equation was wrong. And this is actually wrong. But always in network analysis, the question was asked, what is the voltage at t equals to 1 second, or at 2 second, or at 3 second, or at 1 second, at 0.5 second. They don't used to discuss for t less than 0. They don't used to discuss at t equals to 0 minus. So then we could have written down this particular expression. And how would you draw the expression? How would you draw the characteristics? Can you draw the waveform of it from the network analysis purpose? What I am asking, from the network analysis purpose, you need to draw the waveform of it. So how will the waveform come into action? Initially, what was the voltage? 2 volt was already there. And at steady state, where the voltage will reach? Because here 5 ut is there, so at steady state, the voltage will reach at 5. So initially, the voltage was 2. From 2 to it will reach at 5. Before that, it was 2 only. Before that, it was 2 only. So from 2 to it will reach to 5. So this was the waveform. This was the waveform of yt versus t. Right? What will be the waveform of this particular graph? What I am saying, what will be the waveform of this particular graph? So for t less than 0, it is 0 only. And suddenly at t equals to 0, what will be the value? 5 minus 3, 2. And then this is how it will go. So this will be the waveform of this particular expression. But this is not the correct waveform. This is the correct waveform of yt, no? By network analysis, by simple actual network analysis, we get to know that initially the voltage was 2 and then it reached to 5. So there is no sudden jump actually. But from this particular equation, there will be a sudden jump. Because what this equation will say, for t less than 0, everything is 0. But after that, what is the scenario? Suddenly it is becoming 2 and then going to 5. So this equation was actually absolutely wrong. But this was used for finding out the answers. So there I would not teach all these things there. 0 input response, 0 state response. You would be getting confused. So in the examination, what if they are asking any question for t greater than equals to 0? So you don't even need to think about ut. Forget about this ut. This ut is gone. But they are asking the exact expression. So this is the correct way of writing down the expression. Are you able to understand this point? Here waveform and everything is wrong, right? Let's see more point, more interesting point I will tell you. About this expression only, I will tell you more interesting point. So what we get to know, that this is the actual yt, which is 2 e to the power minus t plus 5 into 1 minus e to the power minus t ut, right? Let's talk about this expression more. Okay. So what this is known as? This is known as 0 input response, and this is known as 0 state response, because this was already there. And here I need to write down for t equals to 0 greater than equals to 0 minus. So this is known as 0 input response, this is known as 0 state response. What was our circuit? This was our circuit, RC, right? This is your yt and this is your xt. Applied input is 5. If there was no initial condition, if here the voltage was 0, initially if voltage was 0, I am saying initially the voltage is 0. So what would be your yt? 5 into 1 minus e to the power minus t by 2 ut. Are you getting the same thing here? Yes. 0 input response. If initially there was no voltage, so what I would have done, the voltage at the steady state will be 5 plus voltage initially 0 minus 5 e to the power minus t by tau. Tau value is 1 and then I can add ut here. So 5 1 minus e to the power minus t ut. There is nothing wrong in this expression considering initial condition is 0. So this is the yt you are having and that's why it is known as zero state response considering initial condition equals to 0. So you are getting zero state response. So this is known as zero state response and this is your zero input response. What is the meaning of that? Zero input response. Zero input response. This is your yt, right? And input is 0 this time. This was the condition for zero state response. Now I am writing down for zero input response. So what I am saying, input is 0, right? This is R, this is C. Input is 0 but initial condition is there which is 2 volt. So RC circuit is there where there is no input, capacitor is having initial 2 voltage. So what will happen? This 2 volt will be discharged to 0. So what will be the yt equation? 2 e to the power minus t by 2, right? So this would be the equation. Here I am not adding ut. Why is that so? Because this is the zero input response. If I add ut here, what does that mean? I am saying that if I add ut here, that means I am saying that for t equals to 0 minus there was nothing. But here I know one thing, that y at t equals to 0 minus was 2 volt. So I am not going to put ut here, but I can say one thing, that this would be there for t greater than equals to 0 minus. Because there is no input, this 2 volt will be completely discharged, but at t equals to 0 minus surely there was 2 volt. So what is really happening? This 2 volt is dying down and 5 volt is charging up. This 2 volt is dying down, 5 volt is charging up. So this is your zero input response which is dying down and this is your 5 volt. Now can you let me know one thing? What will remain at steady state? What I am saying? What is the value of y of infinity? So 2 e to the power minus infinity plus 5 ut is there, no? So 5 u of infinity plus and then minus 5 e to the power minus infinity u of infinity. So u of infinity, you know, it would be 1. You know this would also be 1. E to the power minus infinity is 0. So what will remain? 5 u of infinity. This is the value at infinity. So at steady state, which component will remain? I am not asking the value. At steady state, which component will remain? If I say that my yt is 2 e to the power minus t plus 5 ut minus 5 e to the power minus t ut, and then I am writing down that it is there for t greater than equals to 0 minus. So at steady state, which component will remain? Only steady state, this component will remain. At steady state, only this component will be remain. At steady state, this component will go to 0, and at steady state, this component will also go to 0. Only this component will be non-zero. So whatever the component that is remaining at steady state, that is known as forced response. What it is known as? Forced response. Forced response. Forced response. So if someone asks you what is your forced response, then answer would be 5 ut. And the other thing, whatever that is remaining, that is known as natural response. So if someone asks you what is your natural response, then you will say this particular thing minus this thing. So these are the answer for forced response and natural response. For the natural response, is there is 2 e to the power minus t, you have to write down t greater than 0 minus. So these two another terms are there, forced response and natural response. Why this is known as forced response? Because here this 5 volt has forced the capacitor voltage to reach to 5 volt. Basically at steady state this will remain, everything else will die down. After some time this will also die down, this will also die down, only this guy will remain. So this is forcefully has come into the capacitor, no, forcefully this has remained, 5 volt will remain there. So this component will remain there at steady state. So that's why it is known as forced response and this is known as natural response. Can you make another conclusion from here? That this is coming because of This forced response is coming because of input poles, and this natural response is coming because of system poles. What do I mean by that now? Let's see it. What is your input? What is your input? Input is 5 UT. That means what is your x of s? 5s. Where will be its pole? So this is known as input pole. What do you mean by system pole? So what is your system? What is your system? System is your h of t. And what is your h of s here? Can you let me know what is my h of s? So h of s is y of s divided by x of s. So from here I can see that h of s is 1 upon s plus 1. H of s is 1 upon s plus 1. Where is the pole? Pole is at minus 1. Pole is at minus 1. Okay. So these terms are coming from where this term would have come. If I take the Laplace transform, 2 upon s plus 1 minus 5 upon s plus 1. I am taking unilateral Laplace transform. So 2 upon s plus 1 minus 5 upon s plus 1. So they are coming from s plus 1. That means they are coming from system pole. And from here, where it is coming? 5 by s. This is your 5 by s. So this is coming from input pole. So forced response would be there because of the input poles, and natural response will be there because of the system pole. What do you mean by natural response? Natural response, there it is there because of the system poles. That means if whatever the pole this system is having, because of that whatever that is coming, that is known as natural response, because this is coming because of a system response. And if you have applied an input, because of this pole whatever the output is coming, that is known as forced response. A lot of things are there. You feel like that, sir, there are a lot of things, it is being overwhelming, but let me conclude everything. Okay, this is a very confusing topic, and at 100% of the places this is taught wrong. What is taught that zero input response and zero state response are same, and even if they are taught different, then no intuitions are given. But here the actual intuition is there, that why this is known as zero input response, zero state response, what is the meaning of forced response, what is the meaning of natural response. Forced response means steady state, whatever that is there at steady state. What is the meaning of natural response? Natural response means that is coming because of the system pole. So apart from steady state, whatever that is there, that is your natural response. What do you mean by zero input response? Zero input response means whenever there was no input, still whatever the output was there, that is your zero input response. And what do you mean by zero state response? That even if there was no initial condition, then what was the output? So whenever you write down zero state response, you always add up UT there. But whenever I write down zero input response, I never add up UT there, because at t equals to 0 minus it was there. Are you able to understand these points? Right? All good. So yt equals to this equation. If I write down this equation, yt equals to this equation, this was absolutely wrong. This equation was absolutely wrong. Okay. There is one more benefit of this equation. You can do any operation with this particular equation. What I mean to say is that you can differentiate this particular equation. Let's understand what I am saying. So what is your yt? Yt is 2 e to the power minus t plus 2 e to the power minus t plus 5 into 1 minus e to the power minus t by tau into ut for t greater than equals to 0 minus. This is your yt, right? You have seen the capacitor. Across the capacitor, let's make the circuit only. So what was our circuit? This was our circuit. This was the capacitor. This was R having 5 volt here, and this was your yt, and this was here it was your xt. Not 5 volt. Initial condition was 2 volt. Sorry, initial condition was 2 volt, and this was your it actually. Now at t equals to 0 minus, what I am saying, at t equals to 0 minus, let me know what was the value of it. At t equals to 0 minus, what was the value of it? So at t equals to 0 minus, there was no input, because input came into action at t equals to 0. So there was no input. So what was the current? Current was flowing as 2 by R in the opposite direction. So your current at t equals to 0 minus, your current at t equals to 0 minus, what that was? Minus 2 by R. R value is 1 only, so minus 2 ampere. So your current at t equals to 0 minus was minus 2 ampere. Now if you know the voltage across the capacitor, this current was there in the capacitor as well, no? Right? What I am saying, the current in the capacitor at t equals to 0 minus was minus 2 ampere. You agree to this point? Right? Now what is the voltage across the capacitor? That is Yt. And what is the current? That is It. What is the value of capacitor? C. So It could be given as C dyt by dt. C value is 1 only. So It could be given as dyt by dt. So what is your It? It is dyt by dt. If I differentiate this particular expression, what you are getting? Minus 2 e to the power minus t plus, if you differentiate this particular equation, then what you will get? So let's differentiate this part. 5 ut minus 5 e to the power minus t ut. So how will you differentiate? What is the differentiation of 5 ut? That is 5 delta t. So here you will write down 5 delta t minus, what is the differentiation of this part? So first one as it is, differentiation of second, plus second one as it is, differentiation of first one. So here negative part will come. So here this 0 will come here. So what you are getting? Minus 5 delta t only. Right? What this will say? T minus 0 e to the power 0 will be 1. So minus 5 delta t. These things we have already seen. So plus 5 e to the power minus t ut. So this is what you are getting. Minus minus, this would become plus. So this is the differentiation you are getting. Right? Now this and this is getting cancelled out. So what you are getting? Minus 2 to the power minus t plus 5 e to the power minus t ut. So what this is your It. This is your It, and here for t greater than equals to 0 minus. So this is the expression of your It. Is this expression correct? Let's check. What is the value of current at 0 minus? What is the value of current at 0 minus? That is e to the power minus 0 minus 2 ampere only. Yes, which is absolutely matching. This and this is matching. Can you draw the graph of current for the given circuit? For the given circuit, can you draw the graph of current? Surely I can draw the graph of current. For the given circuit, not for this circuit, for the given circuit. So initially I know that the current was minus 2 ampere. Here I know that the current was minus 2 ampere. Let's draw the circuit here again. So let's do the circuit analysis now. So what is the scenario of current? R, C, here your input was 5 ut and this was your output. This is your current It, and capacitor was initially having 2 volt. So when this input was not there, initially my current was minus 2 ampere. Initially my current was minus 2 ampere. Here initially your current was minus 2 ampere. Then at t equals to 0, what really happened? At t equals to 0, this 5 came into action. So whatever the current that is flowing through the capacitor, the same current is flowing through the resistor as well. So just as this 5 volt came into action, capacitor will not change its voltage instantaneously. So here there is 5 volt, here there is 2 volt. So 5 volt minus 2 volt, what that would be? 3 volt. 3 volt divided by R, that means the current became 3 ampere. So suddenly from minus 2, the current became 3 ampere. Suddenly from minus 2, the current became 3 ampere. Suddenly from minus 2, the current became 3 ampere. And then at steady state, the capacitor became 5 voltage, that means the current went down. Current went down to 0. Here we are not seeing it with respect to any expression, just by the pure circuit analysis I am telling. That initially the current was minus 2 by R, then suddenly 5 volt came into action, so 5 minus 2, the current became 3 ampere, and then it went decayed down, the current became 0. So this was the graph of It. Can you draw the graph of this particular thing? For t greater than equals to 0 minus. For t greater than equals to 0 minus only. So if you draw the graph of this particular thing, that means at t equals to 0 minus, this will not be into action. At t equals to 0 minus, the value will be minus 2. At t equals to 0, at t equals to 0 or 0 plus, what will be into action? This will also be into action, this will also be into action. So at t equals to 0, what you will get? Minus 2, e to the power 0 is 1, plus e to the power 0 is 1. Minus 2 plus 5, 3. So you are getting 3. At t equals to infinity, what you will get? At t equals to infinity, this will be 0, plus 5 e to the power minus 0, this will also be 0. So 0 plus 0 will be 0 only. So at t equals to infinity, this is the same expression I am getting. That means I am exactly getting the correct expression and the correct waveform. Now you pick this particular expression. differentiate. You pick this particular expression, you differentiate it, get the expression of it, and check value of it at t equals to 0 minus. You will not get minus 2 ampere. That means this particular expression was wrong. So you cannot differentiate this expression. If I say that my yt is here, if this was your yt, because this is the correct expression, now you can differentiate it. Any operation you can do. But if this is the operation, if this is the expression yt you write down, so you cannot differentiate it. You cannot do any operation. This is just for the voltage. From this particular voltage, you cannot get the current. If you want to write down the expression of current, then again by the crude way you can write down. What was the crude way? The crude way says you write down the current at t equals to 0 plus. What is the current at t equals to 0 plus? That is 3, and at infinity it is going down to 0 only. So this is the way we used to write down ut. So this was the expression that we used to write down according to network analysis. So in network analysis, by differentiating the voltage function, I could not get the current expression. But this expression is also wrong, because at t equals to 0 minus, you said that the current should be 0. But no, actually the current is not 0. Right? The current is minus 2 ampere. But if I say at t equals to 1, at t equals to 1 second, so this guy will say that 3 into e to the power minus 1, and this guy will also say that 3 into e to the power minus 1, because at t equals to 1 second, this will be into action, plus this will also be into action. So what it will become? 3 into e to the power minus 1. So in network analysis, this was okay for us. Why it was okay for us? Because always we used to talk about t greater than 0. But if we talk at t equals to 0 minus, then the scenes are different. So their equations fail. So according to network analysis, if you are writing down this equation, then these equations are wrong actually. But in network theory, we write down and we solve all the problem and we get the correct answer. In the examination as well, you will get the correct answer. But actual concept is this. Are you able to understand this point? Okay. So zero input response, zero state response, natural response, and your forced response. You have understood everything, right? And now everything will be revised with respect to the next question. So if you solve this question, again the same thing is there. Equations are given. It is a LTI system. Since there is initial condition involved, that means here what you need to apply? You need to apply unilateral Laplace transform. So you need to find yt. Now in that yt, you need to tell what will be zero input response, what will be zero state response, what will be natural response, what will be forced response. So try doing it on your own. Along with that, you find out h of s as well. What will be your h of s? So everything you will try doing it on your own. Okay. So do this question, and then we will again see more questions. But I need to take a break because it's been a long time. So I will take a break and then I will come back. Thank you. Yeah, welcome back. So did you try this question? So this is an LTI system. Input is given. Initial conditions are also given. If initial conditions are given, that means you need to solve it with respect to unilateral Laplace transform. So let's apply the unilateral Laplace transform in this particular equation. So how will you apply it? D square yt by dt square. So y square s of s, y s square y of s minus s y of 0 minus y dash 0 minus. How would you remember? If there is differentiation 2 times, then that means it will end with the differentiation of 1 times. So the confusion would be that, sir, here I should put the dash or here I should put the dash. So you remember that if there is a differentiation of 2 times, then it will end with the differentiation of 1 times. Plus 3s y of s minus 3 y of 0 minus plus 2 y of s is equals to x of s. As of now, we are not going to put the values because I want to see what will be zero input response and what will be your zero state response. So as of now, we are not putting the values. Let's see if the calculation is correct. Everything is correct. No minor mistake. Nothing. Okay, fine. So y of s here, what I can see is that s square plus 3s plus 2. That would be equals to here 3 plus s y of 0 minus, which is actually 0 only. So if this is 0, then we can put 0, no? This is 0 only, this part is 0 and this part is also 0. So at least 0 we can put. That means initial conditions are 0 only. So the 0 I can put. So here what I am getting, y dash of 0 minus, which is non-zero. So y dash of 0 minus plus x of s. I don't want to carry this 0, that's why I put the 0 value, because they are 0 only. So from here what you are getting, y of s as, or let's write down on the next page, y of s as y dash 0 minus divided by s square plus 3s plus 2 plus x of s divided by s square plus 3s plus 2. So from here, if I ask you what is your h of s, so you will put this part equals to 0, and from here directly you can see that my h of s is coming out to be 1 upon s square plus 3s plus 2. So h of s is coming out to be 1 upon s square plus 3s plus 2. So this is one of the answer h of s which was asked. What this is known as? Zero input response, and what this is known as? Zero state response. How will you write down your y of t? So y of t, now the thing is I need to open it up. So y of s, I will put the values now. What is y dash 0 minus? That is 1. So 1 upon s square plus 3s plus 2. How it can be opened? S plus 2 into s plus 1, right? S plus 2 into s plus 1 plus what is your xt? Xt is ut. So x of s will be 1 by s. 1 by s into s plus 2 into s plus 1. There you go, right? So now I need to open it up. Just 1 second, guys. Yeah, sorry for the interruption. So y of s could be written as, now I need to apply the partial fraction, right? So it could be written as 1 upon s plus 1 minus 1 upon s plus 2, right? Because s plus 2 minus s minus 1. So that would be this thing only. Plus, here you need to apply the partial fraction. So I have written down the answer, that is 1 by 2s minus 1 by 2s plus minus 1 by s plus 1 minus 1 by s plus 1 plus 1 by 2s plus 2. So you can do the partial fraction on your own. This is the answer you will be getting. Okay, fine. So this is the answer we are getting. Now what is our y of t? Y of t will be e to the power minus t minus e to the power minus 2t. Should I add ut here? Absolutely no, right? Plus 1 by 2 minus e to the power minus t plus 1 by 2 e to the power minus 2t. But for all of these I need to add ut. So this is your zero input response and this is your zero state response. This answer is incomplete. Why is that so? Because I need to add t equals to 0 minus. Should we check the value? What was the value of y dash of 0 minus? That was equals to 1. So should we check it here? You can check it. What you will do? You will do the differentiation. Y dash t, I need to check at t equals to 0 minus. So if I differentiate this particular part, so here whatever the part would come, I will do the differentiation, but whatever the part would come, that will exist for t greater than or equals to 0. If you differentiate, then there would be no part which will be existing at t equals to 0 minus. Basically this differentiation at t equals to 0 minus will throw 0 only. So I just need to differentiate this particular part and then put t equals to 0 minus. What I am saying, if I am only looking for t equals to 0 minus, that means at t equals to 0 minus, differentiation of this part will be 0 only, because here there is ut connected. So one time you will be differentiating ut, you will be getting delta t. So delta t exists at t equals to 0 only, and then ut will remain as it is. So that exists at t equals to 0 and after 0. That means for 0 minus everything would be 0 only. So I don't need to differentiate this part. So smartly what I can do, I will only differentiate this part and then I will put t equals to 0 minus. So what you are getting, this would be 1, this would be 2. So answer is 1. So yes, it is matching. So this is how I will write down my answer. So if someone asks you what is the zero input response, so if someone asks you zero input response, so this is how you will tell: e to the power minus 2t minus e to the power minus 2t for t greater than equals to 0 minus. And someone asks you zero state response, then you will write down in this manner: 1 by 2 minus e to the power minus t plus 1 by 2 e to the power minus 2t ut. Okay, and here you don't need to write down t equals to t greater than equals to 0 minus, because you know that this will be existing for t greater than or equals to 0 only. So here you don't need to write down anything. The other thing, what is that? Natural response and forced response. So in this particular response, what you can see, that at t equals to infinity, this will be dying out, this will also be dying out, this will also be dying out, and this will also be dying out. So which guy will be remaining at t equals to infinity? Only this guy will remain. So 1 by 2 ut only will remain. Or how you can see, what all are your input poles? Where is your input pole? Input pole. Input pole, or I should write down, what is my x of s? My x of s is 1 by s. My x of s is 1 by s. So input pole will be coming because of this 1 by s. So your forced response will be coming because of this 1 by s. That would be equals to 1 by 2 ut. Are you able to understand this point? The pole is at s equals to 0. So only you need to care about s equals to 0 pole, which is this one. Or simply if you have find out the time domain function, then you know that what part will be remaining at t equals to infinity. This part will be remaining. This part will be remaining, right? Or what you can do, you see the input pole is at s equals to 0. So in all these poles, which one is s equals to 0? This one. So this part will be your natural, this part will be your forced response, rest of the part will be your natural response. So if someone asks you what is your forced response? Forced response. So if you have already find out zero input response and zero state response, then you would know that only this part will be remaining. So this part would be your forced response, and rest of the part will be natural response. A to the power minus t minus a to the power minus 2t plus minus a to the power minus t plus 1 by 2 a to the power minus 2t, and here I need to add ut. Along with that I need to put a condition. There you go. Okay, so these are your final answers. So this is how we solve the problem. H of s we have find out, zero input response, zero state response, natural response, forced response. Okay, all good, all fine. Let's move to next question. xt is the input of an LTI system, should have been mentioned, LTI system. ht is the impulse response, yt is the output. H of s is 1 upon s square plus 3s plus 2. xt is equals to 5 ut. You need to find yt. This question is given, and similarly the same question is given, but here initial conditions are mentioned. So pause the video and solve both of the questions on your own. Pause the video and solve both of the questions on your own. Okay, so let's get started. I hope you would have solved it. First one, y of s divided by x of s, 1 upon s square plus 3s plus 2. S square plus 3s plus 2 we have already seen, it is s plus 2 into s plus 1. What I need to find? I need to find yt. So from here can I find y of s? Yes. Okay, now I know how to do the partial fraction. That was 1 by 2s minus 1 upon s plus 1 plus 1 by 2 s plus 1. Okay, so what would be your yt? Is there any initial condition? This is completely your zero state response, no? This is completely your zero state response. In yt, are you getting any initial condition or anything? Is there any initial condition or anything? No, so this is completely zero state response. Zero input response is not even there. So what is the answer? 1 by 2 minus a to the power minus t ut plus, 1 by 2 minus a to the power minus t this was s plus 2 minus a to the power minus 2t ut. So this is your yt, this is the answer. Okay, now leave one page or at least leave 7 to 8 lines after this question and then write down this question on your own. Okay, so you have written down this question in your notebook. If you are making your own note, if you are studying from the PDF, then you don't need to worry. So have some space and then come back here. You solve this question. So I tried to solve in the same manner, whatever that I have done here. The similar thing I did. The similar thing I did here. Here also the same thing. But here this answer will be wrong. This is wrong. What could be the reason behind it? Because initial conditions are given. No? Do you remember what was your h of s? I told you h of s is ys divided by x of s. Considering initial conditions are 0. Considering initial conditions are 0. Here initial conditions were already 0. So you don't need to worry about that. It was already 0. Initial conditions were already 0. So you don't need to worry about that what will be your h of s? That would be y of s divided by x of s only. You don't need to worry about initial condition. But in the next question, initial conditions are given, no? Initial conditions are given. So what would have happened? Y of s would have been somewhat some 0 input response and some 0 state response. Then you would have put this as equals to 0, and from there you would have got y of s divided by x of s. This is how you would have got your y of s divided by x of s. Are you able to understand this part? So this is how you would have got it. So you completely ignored the zero input response. So from where this zero input response will come out? So this zero input response is necessary, right? So this zero input response have been completely ignored. So let's find out this zero input response. So how we will find out? So our h of s is given, which is y of s divided by x of s, which is 1 upon s square plus 3s plus 2, right? So can I find out the differential equation from this particular equation? Yes, what I can do? I am just multiplying this here and this here. So what you are getting? S square y of s plus 3 s y of s plus 2 y of s is equals to x of s. So from here what I will be getting? D square yt by dt square plus 3 dyt by dt plus 2yt is equals to xt. So actually this was our differential equation. This was our differential equation. From this particular differential equation you would have got this h of s, but initial conditions are non-zero. Actually the initial conditions are non-zero. Are you able to understand this point? So here what we did, when we were finding h of s, we ignored the initial condition. But now if I am having this differential equation, can I write down my y of 0 minus plus s square y of s minus s y of 0 minus y dash 0 minus plus 3 s of y of s minus 3 y of 0 minus plus 2 y of s is equals to x of s. So now I can consider the initial conditions. So you are given h of s, which is surely y of s divided by x of s. But in the question you saw that there are initial conditions involved. So initial conditions are actually not non-zero. For finding h of s, they were put 0. So for finding h of s, initial condition were put 0. Then you got h of s. It doesn't mean that your differential equation is not having any, or your circuit is not having any initial condition. Your circuit is surely having some initial conditions, right? And if you need to find out the yt, so yt will be coming because of the initial condition as well and because of this input as well. So in the yt, both of the response has to be there, initial condition and the applied input. So both of the condition I need to take into action. In the previous one, I was not having any issue with this, because in this question initial conditions are not even mentioned. That means initial conditions are 0. So here I just applied the bilateral Laplace transform. So complete question has been solved with respect to bilateral Laplace transform here. Are you able to understand this point? Because this is completely zero state response. Fully it is zero state response. There are no initial conditions involved. But if initial conditions are involved, then first target would be that you get the differential equation. First target would be to get the differential equation, and after getting the differential equation, you write down this particular step. And from here you would get to know that this part is given 0 only. This part is also given 0 only. So similar thing you will be getting whatever that we have previously got. So that would be y dash 0 minus divided by s square plus 3s plus 2 plus x of s divided by s square plus 3s plus 2. So from here y of t you would be getting, and that we have already seen. Where we have seen it? This is the y of t which we have already seen. This answer you will be getting. Right? So you need to take care of this kind of thing. A very important point. A lot of student does this mistake. Just as they see h of s, that means y of s divided by x of s. So you multiply this x of s here and you get your answer. That is absolutely wrong. You always need to consider initial condition as well. If initial conditions are not mentioned, then it is okay for you, that you can get your y of s divided by just by multiplying x of s here. But if I just multiply x of s directly here without even considering the initial condition, that means something wrong I am doing, because h of s is defined putting the initial condition equals to 0. But actually this initial condition was there into the action. This was there into the action. When you defined h of s, you put that equals to 0. So this came into action, because of that this is the answer we are getting. So 0 input response you know, 0 state response you know, and for this you can define the natural response as well and forced response as well. Natural response and forced response, which we have already previously written, so I can directly copy from here, but let's not copy it, let's write down only. So natural response and forced response. Forced response will be 1 by 2 ut and natural response will be e to the power minus t e to the power minus 2t plus minus e to the power minus t plus 1 by 2 e to the power minus 2t ut t greater than equals to 0 minus. So this is a very good concept based on unilateral Laplace transform. I hope you understood the depth of unilateral Laplace transform. Okay, so unilateral Laplace transform will be used when initial conditions are mentioned, and in all practical circuits the circuit will start from t equals to 0 only, or from a particular time, and in the circuit or in the system you will be having some initial conditions. So mostly practical realizable systems are causal, and in those systems, not mostly, all the practically realizable systems are causal. They will be starting from a particular time, and in those systems you will always apply unilateral Laplace transform. So whenever we study network analysis and whenever we study control system, whenever we study analog electronics, in all these three chapters Laplace transform are used, and those Laplace transform are unilateral Laplace transform. Now you let me know one thing. We studied omega domain and then we studied S domain. We studied omega domain and then we studied S domain. So why this S domain was required? Look, in the omega domain, first thing is you can only comment on the steady state value. Do you remember in the last lecture only when we were studying about eigenvalue and eigenfunction, there I told you that this would be your output for a cosinusoid input, right? You remember that? So this is the steady state value for a particular circuitry. In network analysis, I will tell you that this is the steady state value. There would be some transient part as well. If you want to know the transient part, you need to apply Laplace transform. Look, here you can see transient part, right? These are the transient parts. They will die down. At t equals to infinity, they will die down. At t equals to infinity, at t equals to infinity, everything will die down. Only this forced response will be there. So if you solve any circuitry in omega domain, then only forced response you will be able to get. If you want natural response, you have to use Laplace transform. So first advantage is this one. Now, using the omega domain, can you comment on the stability of the system? H of omega you will have. Based on that h of omega, you can comment on the output. That h of omega will be acting like a filter. Some input frequency, whatever the input frequencies are there, and whatever the frequencies that can be passed through a filter, that will be passed, and you can comment on the output. But can you comment on the nature of h of omega, or can you comment on the nature of ht? Can you comment anything about ht? You can only comment it is low pass filter, high pass filter, band pass filter. All these comments you can do. But in S domain, if I talk about pole, that here the poles are there, here this is the ROC. So you will be able to tell whether it is causal, stable, or all these kind of things. So to comment on the nature of HT, S domain is used. Because from omega domain, you can only comment that what kind of filter is that. And if it is defined in omega domain, that means it has to be stable, then only it will be defined. So mostly you can only comment one thing. What is that? That you will be able to comment that what kind of filter is that, what kind of frequencies it will pass. But if you talk about the system in S domain, so if you just know the pole, if you just know the ROC, then you will get to know that whether it is causal or it is stable, or if you want to make it anti-causal, then what should be the ROC, and all these kind of things you will be able to comment. So that's why we moved from omega domain to S domain. that was the necessity that you need to introduce another sigma. Okay, initially you are having x of omega versus omega. Now you have to introduce another sigma, that's sigma where ROC is defined, real part of S. You have to introduce that real part of S just because of this fact. Is that clear to you? Okay, so just an interview question in gate examination, it cannot be asked, but if someone asks you that why you moved from omega domain to S domain, then this would be the answer. So we are not writing it down, we are not writing down anywhere, but I will keep some space, one page of space I will keep, and whatever that I have said, that you can write down in your notes. Okay, and if you are making your own note, then there is no issue. So I will keep one page blank, there you can write down whatever that I have said, omega domain versus S domain, and you can go to ChatGPT can talk more, right? ChatGPT can tell you more about this, that why you moved from omega domain to S domain. They will tell about, you can keep on talking to ChatGPT. This is what I recommend to all the students. Let's just say you have studied everything, now you are having some free time. Okay, you feel like that today, sir, I don't want to study, I want to relax. But when you are relaxing, you feel like that, let's understand something. So go to ChatGPT and talk to him. Okay, don't talk about personal life. Never ever reveal anything about your personal life to AI. Okay, never ever, because that is very dangerous. It is more dangerous than what it looks like. So never ever talk about personal life to ChatGPT, but talk about these things. Talk about electronics. That this is what sir has taught. If I want to know more about this Laplace transform, then I can know more about. If I want to know more about x of omega, then let's know more about x of omega. ChatGPT will not help you solving in problems, but it can help you to strengthen your concept more. Whatever that I teach, that is more than enough. I am just telling that whenever you are having free time, this is how you can spend that particular free time. If you want to spend the free time doing anything extra, that also you can do. But if you want to say, if you want to feel like that, you feel like that, sir, in the free time I want to learn something, so this is how you can learn it, and that would be an interesting part only. It's not that you are learning some formula there, you are learning some how to solve the problem. All these things you are not learning, you are learning the electronics. So this is what you can do in your free time, and this is what I do. Okay, so this is from ChatGPT, helps me a lot in my teaching, because ChatGPT, you can talk to ChatGPT, right? And based on your input, they will give the response. So that is something pretty good. So you can also use it in a good manner, right? There is something called initial value theorem and final value theorem, which you will study in network analysis as well, and you will study it in control system as well. But let's study it here as well. Okay. So first thing is that the concept of initial value and concept of final value is defined only for causal system or causal signal, you can say. Concept of initial value and final value is defined only for causal signals. Why is that so? Let's just say there is a non-causal signal. Sorry, there is an anti-causal signal. This is anti-causal signal. So there is nothing called initial, no. Someone will say that, sir, t equals to minus infinity is my initial value, because it is starting from minus infinity to it is going to 1, to minus 1. Or if it is non-causal, so starting from minus infinity and it is going till 1, right? Or it is non-causal like this, starting from minus 1 and going to plus infinity. So if I say initial value, that means I am talking about t equals to 0 plus, and this t equals to 0 plus will make sense only for causal signal. So initial value and final value is defined only for causal signal only. So this is the first condition, that initial value, the concept of initial value and final value is defined only for causal signals. Now what do you mean by initial value? That means you need to tell the value at t equals to 0 plus. So what is the value at t equals to 0 plus? That is 1. And what is the value at t equals to infinity? That is known as final value. So what is the value? That is 0. Right? You put t equals to 0 here, e to the power 0 is 1, ut is also 1 at t equals to 0 plus, and at t equals to infinity, this is 1, but e to the power infinity, e to the power minus infinity will be 0. If I ask you here, what is the value? If you put t equals to 0 here, so e to the power 0 will be 1, cos 0 will be 1. But if I ask you at infinity, the value will be 0. Here what is the value? At t equals to 0 plus, the value is 1. And what is the value at infinity? Infinity. The value at t equals to 0 plus 1, and at infinity, infinity only. If you put e to the power infinity, that would be infinity only, and cos 3t will be some value between minus 1 to 1. You remember the graph, right? This kind of graph you will be getting. So it will keep on rising up like that. So it will go to infinity. if I ask you the value at t equals to 0 plus, what is the value? 1. Here if I ask you the value at infinity, what will be the value? Can't comment, right? Can't comment. At t equals to infinity, what is the value? You cannot comment. It would be somewhat between -1 to 1, but it will be oscillating. So you don't know what is the value. Are you able to understand this point? Is this signal oscillating? Yes. The signal is oscillating. But what is the value at t equals to infinity? You cannot comment. Is this signal oscillating? Yes, this is also oscillating, no? You remember the graph, right? This will be the graph. In between this would be the graph. So this is also oscillating, but it is dying down to 0. This signal will die down to 0. This signal is increasing to infinity. So you can comment on the infinite value. Here what you will say, it is undefined. Here you will say it is undefined. Undefined. This is also you will say it is undefined. Undefined means infinity. But here you cannot even comment, right? Because it will be oscillating between -1 to 1. Whatever the value is, you cannot comment. What about this one? At t equals to 0 plus. So at t equals to 0 plus, RT will throw 0 and this will throw 1. So value is -1. But at infinity, what is the value? That would be infinity only. Because this guy is good. At infinity, this will say that I will be 0. But at infinity, this will say that I will be infinity. So infinity minus 0 will be infinity only. So this is also undefined. So this is the meaning of your initial value and final value. And another thing is that concept of initial value and final value is only defined for causal signals. So if xt is given and they ask me what is the initial value of the given function, what is the final value of the given function, then this is how I can find it. So now what is the requirement of initial value and final value theorem? So if x of s is given, and then they ask you what is the initial value. So you don't need, from x of x you don't need to find x of t and then you put t equals to 0 plus. This process you don't need to do. So to reduce this process, we have developed this initial value theorem and final value theorem, and they are applicable for only causal signal, and for causal signal unilateral Laplace transform and bilateral Laplace transform both are the same thing. So kind of you can say that initial value theorem can be applied for unilateral Laplace transform only. What I am saying, it is applicable for causal signal, and for causal signal you know that unilateral Laplace transform is equal to bilateral Laplace transform, right? So if you are calculating a Laplace transform, that would be unilateral Laplace transform only, and which is equal to bilateral Laplace transform, and ROC will be right to the rightmost pole, right? So that's why kind of always it is said that, or always initial value theorem and final value theorem is taught after unilateral Laplace transform, because it is applicable for causal signal, and causal signal will have the same unilateral and bilateral Laplace transform. Okay, so these are not the points which anyone will ask you. This is a very straightforward theorem. If you want to find something, you can find it. That's it. Okay. So initial value theorem, that means you need to comment on the value of xt at t equals to 0 plus. So the condition is that x of s should be a proper rational Laplace transform. It should be a proper rational Laplace transform. What is that? What does that mean? That power of numerator should be less than the power of denominator. So power of denominator should be larger. That means s upon s square plus 1, this is accepted. But s square upon s plus 1, this is not accepted. Or s upon s plus 1, this is also not accepted. Are you able to understand this point or not? Why this is the condition? Because to apply the initial value theorem, you do not want any impulses or its differentiation. What I am saying, to apply the initial value theorem, only one condition is there. What is that condition? That there should not be any impulses. There should not be any impulses or its differentiation, differentiation at t equals to 0. Let's just say this is the example, s square plus 2s plus 1, right? You saw that degree of power of numerator is more than the power of denominator. So what is this? This is improper. And if it is improper, what will you say? That your initial value theorem is not applicable. Initial value theorem not applicable, right? Now what is this initial value theorem? So to find out the value of xt at t equals to 0 plus, or I can say x of 0 plus will be equals to limit, here I will put the limit of s. For which function I will put? So I will multiply this x of s with s. I will multiply this x of s with s, and then I will put the limit of s tending to infinity. So this is known as initial value theorem. What is this initial value theorem? The value of xt at t equals to 0 plus will be equals to, if you are having its Laplace transform, so s into x of s and then put s tending to infinity. But the condition is x of s should be proper and rational Laplace transform. Proper and rational. This is improper, gone. Okay, and why it is gone? Because if you find it out, what is your x of s? X of s is s plus 2 plus 1 by s, and from here x of t, what I can see, x of t is delta dash t plus 2 delta t plus ut. And I told you one thing, there should not be any impulses and its differentiation at t equals to 0 plus, at t equals to 0. So at t equals to 0, if you are having these guys, that means you cannot define the initial value. Is that clear to you or not? Okay, so to define the initial value, there should not be any impulses or its differentiation. This is the only requirement, and the other requirement that xt should be causal, that is there for final value theorem as well. So requirement is understood, right? Very simple thing, should not be having any impulses. That means the transfer function could not be improper, or you can say Laplace transform could not be improper. And what is the theorem? To find out the value at t equals to 0 plus, multiply your x of s with s and then put limit s tending to infinity. Here it is 0 plus, so here you will put infinity. And in the final value theorem, here it will be infinity, here you will put 0. Okay, you can find out for these kind of example, what is your x1 of s? That is 1 upon s plus 2. Proper? Yes. So what you need to do? Multiply with s, multiply with s. Now put limit s tending to infinity. So if s is tending to infinity, that means s can be replaced with s only, and s plus 2 can also be replaced with s, because s is tending to infinity, that means this s is very much larger than 2. So both get cancelled out. What is the answer you are getting? 1. Are you getting the same answer? Yes. Okay, so this is how you can solve it. For all these examples you can solve it. For all these examples you can solve it. Here 1, 1, minus 1, everything would be solved. Let's solve for this one. 1 upon s square minus 1 upon s plus 1. Right? This will be the Laplace transform. 1 upon s square minus 1 upon s plus 2. Really sorry, s plus 2. E to the power minus 2t is there, no? Right? So I multiply with s. If I multiply with s, then this will be gone, and here s would come. Multiply with s, and then I need to put a limit s tending to infinity. So I am putting limit s tending to infinity. So 1 by infinity will be 0 minus. Here what will happen? S divided by s, because s is very much larger, so this 2 can be ignored. So 0 minus 1. What is the answer you are getting? Minus 1. The same answer you are getting. So this is how you need to apply the initial value theorem. Look, if this signal is already there, then why would I apply any theorem? I will just put t equals to 0, I will get my answer. But what if x of s is mentioned? What if this kind of x of s is mentioned? So will you go to x of t? That will you find out its inverse Laplace? Pole location and everything, you have to do all these kind of things. So you cannot do these kind of things, right? So what you will do? You will say that, sir, it is rational and it is proper. Rational and proper. So that means I can apply the initial value theorem. Initial value theorem I can apply. Right? xt is causal as well. This would be given in the question. This would be given in the question, or by default you consider it. If it is not given, then by default you consider it. 99.99% chances are there that it will be given. You need to find x of 0 plus. So what you will do? Sir, x of 0 plus is equals to 0 plus, that means limit s tending to infinity s into x of s. So sir, whatever it is given, I will multiply this with s. So 2s cube plus 5s square divided by 12s divided by s cube plus 4s square, s cube plus 4s square plus 14s plus 20. Now s is very much larger. S is very much larger. That means s cube will be very larger than these guys. Right? Infinity to the power 3. Very large will be very, very, very large. This will be very, very large, and this will be very large. S is very large, then s square will be very, very large, and s cube will be very, very, very large. S is very large, s square will be very, very large, S cube will be very very large, right? So very large, and these are small. For this particular guy, these guys are small. So what you need to do, you will ignore these parts. This guy will be ignored, this guy will be ignored, and same goes downward. This guy will be ignored, this guy will be ignored, and this guy will be ignored. So what you are left with, limit s tending to infinity, 2s cube divided by s cube. So this and this is getting cancelled out. Now there is no limit of s. So what is the answer you are getting? 2. So if someone asks you what is the initial value of this particular x of s, so you don't need to find x of t from here. You will just apply the initial condition, and you will tell that in time domain at t equals to 0 plus, you will be getting the value at as 2. Okay. What about this one? From here you can find out, here ROC is mentioned, real part of s greater than minus 2. So what will be the pole location here? Pole location will be at minus 2 plus minus 3j, and you can say that if this is the condition, that means it is causal. If it is causal, that means you need to find the value of xt at t equals to 0 plus. So here this is easy because I can find the xt value. But if I don't want to find the xt value, if I find it directly by the theorem, then how will I find it? So limit s tending to infinity, s into x of s, s into x of s. Now what is the scenario? S is very large. S is very large. So this guy will be very larger than 9, and s will be very larger than 2 as well, right? So what I am saying, if s is very large, then this 2 can be ignored, this 9 can be ignored. So downward what you will be getting, s square. Here also this 2 can be ignored. So upper side what you will be getting, s square only, and which is getting cancelled out. What is the answer? 1. Or what you could have done, you could have find xt from here. What would be xt? S upon s square plus a square, that means cos 3t, and s is replaced with s plus 2, that means e to the power minus 2t cos 3t ut. And from here only you could have told 0 plus, the value will be 1 only. Okay. So both ways are there, but in these kind of questions, that's why the initial value theorem is used for these kind of questions. Otherwise these kind of questions are there, then no issue. So here only one condition is there, that this x of s should be proper and rational and proper. So it should be rational as well, along with that it should be proper as well. Why rational? Why rational? Because let's just say on the upper side there is e to the power s divided by s plus 1. So the meaning of 0 plus has been lost, no? E to the power s, what is the meaning of e to the power s? That means, or e to the power minus s, let's keep e to the power minus s. So what will be its inverse Laplace? E to the power minus t, u of t minus 1, and here also u of t minus 1. Now this signal is starting from 1 only, no? So there is no meaning of 0 plus. There is no meaning of 0 plus, right? So it has to be causal and starting from 0 plus as well. So that's why it cannot be improper. It has to be proper and rational. Proper and rational. So it cannot be irrational, right? E to the power s term cannot be there. So proper and rational it should be there. Well and good. Now there is something called final value theorem. That means you will find the value of x at t equals to infinity. Now what is written here? Xt should be causal, and poles of s into x of s. What is written? S into x of s should lie in the left half of s plane. Okay. What does that mean? That means sigma greater than equals to 0, or you can say real part of s greater than or equals to 0 is excluded. So where should the poles lie? The poles should only be lying in this particular region. In this particular region. And what do you understand by that? For a causal signal, if all the poles are lying in the left half of s plane, for a causal signal, if all the poles are lying in the left half of s plane, then what will be its ROC? Right to the rightmost pole. That means ROC will surely include j omega axis. What does that mean? That your x of t will be absolutely integrable. So basically the condition is x of t should be absolutely integrable. Then only you can find it. But there is a catch. Sir, if x of t is absolutely integrable, then why you are not finding the poles of x of s? Why you are finding the poles of s into x of s? Why you have written s into x of s? Why you did not write x of s? So just let me know one thing. If your xt is equals to ut, is this absolutely integrable? Absolutely integrable? No. Right? It is not absolutely integrable. But if I ask you the value of xt at t equals to infinity, what that would be? Sir, it will always throw 1 only. Even if it is not absolutely integrable, still you are able to find its final value. Why? Why is that so? Because what was your x of s? That was 1 by s. The pole was there at s equals to 0. The pole was there at s equals to 0. And here what did I write down? The pole should lie strictly in the left half of s plane. That means this condition should not be there. Strictly in the left half of s plane, that means real part of s greater than equals to 0 is excluded. That means this should also be excluded. But notice one thing, what I have written, s into x of s. So here this is your x of s. If I find s into x of s, what I will get? 1. So where are the poles? There are no finite poles. So your job is done. Yes, I can find out the value. I can find out the final value. So the scenario is one pole at origin is accepted. Again I am repeating, one pole at origin is accepted. What I am saying, all the poles should be lying in the left half of s plane. Here, 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 pole should be lying here, 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 whatever it is. But if you are having one pole at origin, then it would work. But if you are having two poles at origin, what does that mean? That xt is rt. So what is x of s? 1 upon s square. So if you are having two poles at the origin, if I ask you what is the value at t equals to infinity, you will say, sir, rt will keep on rising up. So undefined, or you can say infinity. So now initial value, now final value theorem will not be applicable because you are having two poles at the origin. Two poles at the origin. So one pole at the origin is acceptable, but two poles at the origin will not be acceptable. So if I had written with respect to x of s, so how I used to write, how I would write that, sir, for x of s, all the poles should be in the left half of s plane, but one pole at s equals to 0 is accepted. So this could be the other way of writing it down. What could be the other way? The other way could be, the same statement could have been written in this manner, that all the poles should lie in the left half of s plane. But and a single pole at s equals to 0 is acceptable. Is also acceptable. So this is the way I should have written it. But what did I do? I multiply x of s with s. That means here, if I multiply with s, what I will be left with? 1 by s. So now this pole is at origin, but as per this statement, the pole at origin is also not accepted. The pole only before origin will be accepted. As per this statement, what I am writing down, real part of s greater than equals to 0 is excluded. That means here, even if your pole is here, that will also not be accepted. Is that clear to you or not? Okay, so if two poles are coming at the origin, then it is not accepted. That's why I multiply with s x of s. So any of the statement you need to remember, okay? And this is about the origin only. Let's just say if my poles were here, single poles were here. What I am saying, single poles were here. When you will get single poles here? When your xt is cos omega naught t ut. What will be the poles? Plus minus j omega naught. So single poles you are getting. Let me know one thing, can you define the final value? No. I cannot tell, I cannot comment, because final value will be oscillating between -1 to 1. So again I cannot define the final value. So when I said single pole is accepted, that is accepted only at origin, not on the j omega axis. So all these would become very confusing, no? Are you able to understand this point? That first you are saying that all poles should be lying in the left half of s plane, then only this point is accepted for single pole. So this is the way, if you want to remember, you can remember. In your mind, what you will remember, that all the poles should be lying in the left half of s plane and single pole at this origin is acceptable. So you can kind of remember the diagram. What you can remember? Kind of you can remember the diagram. Let me draw the diagram for you. So all the poles here is the pole, here is the pole, wherever the pole is there, I don't care. All these poles are accepted. Here there is pole, here there is pole. All these poles are accepted and only one pole at the origin is accepted. So this is the accepted condition. That's it. For applying your final value theorem. So you will draw this diagram. First you will draw the pole zero diagram and then you will apply the final value theorem. So let's draw the pole zero diagram for this one. One pole is at 0 and another pole is there at -1. So is this acceptable? Yes, because single pole at the origin is accepted. So don't do this as x of s, nothing you need to do. So now yes, I can apply the final value theorem. And what is this final value theorem? You need to find the value of xt at t equals to infinity. So what you will do? You will put the limit of s, but you will multiply x of s with s, and the limit will be put s equals to 0, s tending to 0. Okay, very easy. Here what was the scenario? S tending to infinity, because you are finding out the value at t equals to 0 plus. Similar thing, s into x of s. Here you are finding the value at t equals to infinity, you will put s tending to 0. Can I find out x1t from here? Or let's not find out x1t from here, let's find out the value directly. So what will be the value directly? Limit s tending to infinity, s into x1s. That would be limit s tending to infinity 1 upon s plus 1. So if you put infinity here, what is the value you are getting? 0. So yes, this is the answer. This is the answer you are getting. Right? This is the answer you are getting. All good? Or you could have find out the x1t as well. What would be x1t? Can you break it down? Yes, it could be broken down. It could be broken down in this particular manner. So what would be your x of t? 1 minus a to the power minus t into ut. Okay, something wrong. We are doing it as tending to infinity. So it would be 0 only. One second, something wrong I am doing. A to the power infinity is 1 only, no? So here what is the issue? Oh, sorry, as tending to 0, really sorry. Blunder. As tending to 0 here, right? So what will be the answer? 1. Answer will be 1. You are applying the final value theorem, no? So as tending to 0. And from here as well you can find x1 infinity. So 1 minus a to the power minus infinity. What that would be? 1 only. So final value is 1 here. So 1 upon s into s plus 1. For this particular graph, the final value is 1. Final value is 1. So here you draw the pole zero diagram and you get to know that one pole at the origin is accepted and rest of the poles are there in the left half of s plane. So your job is done. Okay. So you can find out the final value like this. Let's go for this one. 1 upon s square plus 1 upon s square upon s plus 1. So another pole and then another pole. S square means there are two poles at the origin. What about the pole? S square is equals to 0. So from here you will get two poles, 0 and 0, and then s plus 1 is equals to 0. So another pole you will be getting at -1. So this guy was acceptable, but two poles at the origin is not acceptable for sure. Right? Are you able to understand this point? And you can find out the x2 of t as well. Two poles at the origin was not acceptable. So what I will say, final value theorem not applicable. Not applicable, or kind of you can say that final value will be undefined. Final value is undefined. Okay, final value is undefined. This will be the final answer. But let's do it with respect to time domain. So let's find out x2 of t. So for that what I need to do? I need to do partial fraction. So here if I do s square plus s minus s square. 1 by s if I do here, and here 1. So s plus 1 minus s. Yeah, the job is done. So what we are getting? 1 upon s square minus 1 by s into s plus 1, and it can be broken down into 1 upon s square minus 1 by s plus 1 minus 1, s plus 1 minus s, so 1 upon s into s plus 1. So here plus would come. So this is how it can be broken down. Okay, partial fraction I have done. So how I thought, 1 upon s square I put, 1 upon s plus 1 I put. If this s square goes here, so s upon s plus 1 I will be, s here I will be getting, and s plus 1 I will be getting here. So s plus 1 minus s, what that would be? 1 upon s square plus 1 upon s square into s plus 1. So this is the expression I am getting. Then I need to break down this one, which is very simple, 1 upon s minus 1 upon s plus 1. Then there is a negative sign, so this would become plus. So this is the answer we are getting. Okay. So what is your x2t? Just from here only I could understood that r of t will come into action. So yes, r of t is coming into action. So this r of t will ruin everything. Okay. This is the problem. This r of t is the problem. This is ut and this is e to the power minus t ut. So what will be the value at infinity? This r of t will say infinity minus this will say 1, this will say 0, the value will be infinity only. Surely it is undefined. Okay. Let's go to next one. Pole 0. So in case of initial value theorem, what you will do? You will see proper, improper. But in case of final value theorem, you don't need to see proper, improper, you just make the pole 0. So one pole is at 1, another pole is at minus 3. Not accepted. Not accepted. That means final value theorem not applicable and final value is undefined. Final value is undefined. And you can check as well. How will you check? By doing the partial fraction. So should I do it for you or you can do it on your own? So let me do it for you. Since it is a recorded lecture, so I cannot do anything. I have to do it. 1 upon s minus 1. So if s minus 1 goes here, upper side you would need s plus 2 actually. S plus 2 you require. So it would take time actually. So let's make it a by b plus 1. So if I multiply with s plus 3 and then put a minus 3, so what I will be getting? Minus 1 upon minus 1 by 4. So a will be 1 by 4. A will be 1 by 4. And then I multiply with s into 1 and then I put a 1. So 3 by 4. B will be 3 by 4. So this will be the scenario. B will be 3 by 4. Okay, by that method that you multiply with s plus 3 first. So if I will multiply both of the side s plus by s plus 3 and then I will put s equals to minus 3. So this will throw minus 1 minus 4. So 1 by 4. So value of a will come out to be 1 by 4. Right? And then I will multiply with s minus 1. So I will put s equals to 1. So what I will get? 3 by 4. So s equals to 1 I will put. So value of b I will get 3 by 4. So from here what do I see? 1 by 4 e to the power minus 3t ut plus 3 by 4 e to the power t ut. And they will say that they will mention the ROC. What will be the ROC that will be mentioned? It will be mentioned in the question. ROC will be mentioned as real part of s greater than 1. This will be mentioned there. That means it is a causal signal. If it is a causal, then ut is coming. Someone will have a doubt that, sir, why you are not writing u of minus t? ROC will be mentioned. Okay. And if it is not mentioned and they are asking final value, that means you have to consider everything is causal. The bottom line is, if nothing is mentioned, consider that causal only. Okay, because in control system and network analysis, everywhere causal signal will be used. So yeah, if you find out the value at infinity, what you will do? E to the power minus infinity is 0, but here e to the power infinity will be infinity. I told you undefined. What about this one? Where will be the poles? Poles will be here, plus minus j omega naught. And I told you only condition that is defined here as well, final value theorem not applicable. And final value undefined also you can say, or you can say final value will be oscillatory. So actually if single poles come on j omega axis, this you will study in control system. If single pole come on j omega axis, here if single poles comes, then it will be marginally stable, it will be oscillatory. And if multiple poles are coming, then it will be unstable. That means it will throw infinity value. So here I cannot say the value will be infinity. I will say that value will be somewhat oscillatory. I don't know. So again I can say that final value is undefined. Final value is undefined because the value will be somewhat between minus 1 to 1, undefined. But better explanation would be that final value will be oscillatory. And how do I get to know the final value will be oscillatory? So if my poles are there on j omega axis, not on origin, on j omega axis, dropping the origin, and single pole should be there. It's not that double pole should be there. Single pole should be there. So if single pole is there on j omega axis, that means it will be marginally stable. That means output at final value will be oscillating. And if double poles are there like this, that means final value will be infinity only. Okay. So although don't care about these things in signal system, but in control system again you will study this initial value theorem, final value theorem, and there you will be able to comment all these kind of things, right? And from here you can directly see that what is your x of 4t, that is sine omega naught t ut, sine omega naught t ut. So value at infinity will be oscillating only. What about this one? Here where are the poles? Poles are there at -3 plus -2 plus -3j. So where are the poles? Poles are at -2 plus -3j. Here there are the poles, and this is the acceptable condition. This is accepted. Yes, final value theorem applicable. Because pole should lie in the left half of S plane. Anywhere it could lie, and one pole on origin will work. So it is accepted. Yes, it is accepted. So I can apply the final value theorem. So if I find this value, then limit s tending to 0, s x of s. So s into s plus 2 divided by s plus 2 whole square plus 3 square. So s equals to 0 I need to put. What I am getting? 0 into 0 plus 2 divided by 0 plus 2 whole square plus 3 square. All I need to take care is that it should not be 0 by 0 form. So am I getting 0 by 0 form? No, 0 by 9, which would be equal to 0 only. So x5 of infinity is equals to 0. This is the final answer. And you can check as well. How will you check? What will be your x5 of t? E to the power minus 2t sine 3t, not sine 3t, cos 3t ut. Cos 3t ut. And if you find out the value at infinity, so e to the power minus infinity will be 0 only. There you go. Okay. This kind of thing is there. It is improper. But did I tell you that improper proper is an issue? No. There is no issue about proper or improper. Right? So there is no issue about proper or improper. Only concern is where are the poles. So pole is there at origin only. And one pole at origin is still fine. So I don't have any issue. So proper, improper, nothing you need to see. Only you need to see pole at the origin. Pole location. If they are in the left half of S plane or single pole at origin, then everything is fine. So what is the x6 of S you are getting? S plus 2 plus 1 by L. Okay, first I need to apply the theorem. So first I will solve with respect to the theorem. So what will be the value at infinity? X6 value at infinity. So limit s tending to 0, s6 of s. So it will be s square plus 2s plus 1 with the fact that limit is tending to s tending to 0. So if I multiply this particular thing with s, what you are getting? S square plus 2s plus 1. So s tending to 0, what will be the answer? 1. So this is the answer, that is 1. And let's check what will be your x6 of t. S6 of t will be, or let's write down s6 of s, that is s square divided by s, that would be s. 2s divided by s, that would be 2. 1 divided by s, 1 by s. So from here what would be your s6 of t? That would be delta dash t plus 2 delta t plus ut. So they will be around 0 only. At infinity only this guy will remain, no? So if I ask you what is the value of x6t at infinity? So this would be 0, this would also be 0, but this would be 1. So what is the answer? 1 only. So verified here as well. Okay. So this is the end of your Laplace transform. If some topics are remaining, like in Fourier transform, Hilbert transform, there is something called Hilbert transform. That topic is remaining. Some log-based problems are there. Those topics are remaining. So those are miscellaneous, which we will cover. Don't worry about that. But on top level, your Laplace transform has been completed now. Now we will move to the discrete part. So now we will see Fourier series, Fourier transform, jet transform, all are in the discrete part. Okay. So let's start the discrete part now. Thank you very much.